Also record the
Our next speaker is Dr. Lepana Antonio Gerardo. Dr. Lepana is an AI instructor at the Volta Institute. He holds 2 degrees from the Lewis University in Rome. At the Volta Institute, he teaches professionals across various sectors about what artificial intelligence is and best practices of artificial intelligence, guiding them on how to apply AI effectively to improve their work and decision-making process. In addition to his academic activity, he is a tech entrepreneur helping organizations and professionals implement AI in real tech wall settings. At just 25 years old, he is deeply committed to advancing AI research, spreading knowledge, and contributing to the development of next generation of artificial intelligence systems. Please join me in welcoming our keynote speaker, Dr. Lepana.
Thank you very much for introducing me, Kiran. And right now I will share my screen to talk about what the future of intelligence is. So what the future of artificial intelligence is. There is one of the most important things because we have spoke about what the future of the economy is, of the industries is, which will be empowered by artificial intelligence. And that is good because the future of economy will be empowered by artificial intelligence. This is 100% true, but right now we have to talk about what the future of the future. But right now we have to talk about not only what the future of industries is, but what the future of artificial intelligence itself is. And we will dive into the technicalities and the technical aspect of AI. Let me share my screen so I can talk about that. Thank you very much for introducing me. And all right, here we go. So the future of artificial intelligence, when artificial neural network meet living brain cell, because we have spoke about artificial neural network, but what artificial neural networks are? Artificial neural network are the emulation and simulation of a biological neural network, which is one of the most important things in order to describe intelligence. And this is something that talks about the future of AI when artificial neural network meet living brain cell. So artificial neural network in their architectures have 3 different kind of layers. The input layer, when they take, for instance, the written text or the images, when we're talking about convolutional neural network. Then they have the hidden layer, where there is the processing and the reasoning itself. And then there is the output layer, when there is the result, of something, of some reasoning. And this is the mimic of intelligence, because we are talking about what intelligence is and what artificial intelligence is. So we right now know that a machine can be intelligent. A machine can be intelligent artificially. So with Geoffrey Hinton, there is considered the godfather of AI. In 1986, has discovered artificial neural network, and then in 2006, deep learning neural network with more set of hidden layers. He has said that a machine can think, and there is the Turing test with which we know that a machine can think, because the Turing test is going to evaluate the intelligence of a machine by making humans believe that also the machine is human. So these are the artificial neural networks, which are going to represent the most concrete thing to have artificial synapses, which is similar to the biological synapses, wherein human intelligence or animal intelligence happens. So let's see about the biological neural system. So the biological neural system is something that we have, which is going to inspire the artificial neural system. That is very important because it is going to be inspired, the artificial neural system, by the biological neural system, since scientists have said to each other, all right, we have to make a machine intelligence. So they have happily said, in order to make a machine intelligent, we need to emulate what is going to be the human brain. So they have emulated the human brain, and there is this simulation with artificial neural networks. So this was a brand new innovation in the 80s that has given form of a new kind of intelligence that is artificial. So that is why it was extremely innovative and still is to these days extremely innovative. But this is still the concept of weak AI. Today I want to talk, and I will talk about the future of AI. How? By introducing what is the bio-digital integration. So there is the convergence point where silicon meets living cells. Let me explain myself better. A couple of months ago, it was released the first form of synthetic biological intelligence with biological components unifying, so living brain cells unifying with mother cards of an hardware. This is one of the most innovative factors with the living brain cells, which were unifying with the mother card of an hardware by making happen a reasoning that is synthetic. It's not only biological, it's not only artificial, but it's the union between biological component and artificial neural network, which is something in a positive way crazy, because it's not like 15 years ago when scientists were thinking about the hypothesis of having a machine that thinks, because this is true, a machine can think. It's not like, all right, humans can think, yeah, there is a biological intelligence and there is also an artificial intelligence. It's the union between artificial intelligence and the biological intelligence with the biodigital integrations. That is why I've said when I was introducing this work that I will talk about the future of intelligence, not only the future of economies and industries due to positive externalities from artificial intelligence, but the future of intelligence itself, which is not only biological, because there won't be only human working on things. There is not only artificial, because there won't be only machines working on things, but it will be synthetic, with a synthetic biological intelligence and a biodigital integration. Indeed, the first computer which was released, it was the CL1. There is the computer when silicon meet neurons. So where the biological synapses, living brain cells were in the computer. This is crazy. This is crazy. And this is also enthusiastically crazy because, we are thinking about intelligence. We can think about a human mind or an artificial intelligence. Right now, we can paradoxically think out a biological components which meets artificial components. So, and then we will also see the future of intelligence. As I said, there is a synthetic union between biological and artificial system. This is one of the most important things. Now, I will move on beyond the digital intelligence because, most of you guys can say that artificial intelligence is the last invention of mankind. And this may be true, because the next inventions will be done with the help of artificial intelligence. And personally, if I ever invent something, if I ever make something, it will be done with the help of artificial intelligence because I live with artificial intelligence. I have AI agents that work for me, and I help people by implementing their AI agents. I help professionals across various sectors and also companies and organizations for this, and I offer those services in an efficient way. And I already live with artificial intelligence. So according to my personal experience, I deeply believe that artificial intelligence is the last invention of mankind. But we are going to go beyond digital intelligence. We are going to go beyond what a digital intelligence is. And artificial intelligence indeed is evolving past traditional computation. And we are entering right here and right now in an era of SBE. There is a synthetic biological intelligence. It's a union between artificial components and biological components, where digital algorithms are going to meet biological neurons and interact directly with them. And this convergence is not just a metaphor. it's an engineering reality, because whoever is working on emerging technologies knows that this is an engineering reality. And let's see the traditional AI, which is based on algorithms and digital processing, which is similar to the AI that we have nowadays with general artificial intelligence. Then we will have the synthetic biological intelligence. As I said, there is a union between digital algorithms and biological neurons, and this is an engineering reality, because with computer CL1, it's happening right here and right now. But before understanding what are the positive aspects among a synthetic biological intelligence, which is the union between artificial components and biological components, we need to understand what is a biological neural network, because there will be a much less consume in terms of power from biological neural networks, since the human brain contains approximately around 90 billions, here it says 86 billions of neurons, and around 100 trillion synaptic connection, which are enabling real-time perception in the terms of processing information, of decisions making, and so on. So 86 billion neurons in the human brain. This is crazy. And 100 trillion synaptic connections. And this will enable the complex processing. But the magic, the miracle of human brain, it happens now that we do not consume that much. We need to eat, we need to go to the bathroom, we need to sleep, we need all of those things. But in terms of power consumptions, we just need 20 watts, all right? So we just need 20 watts, and there is a remarkable efficient processing. And in terms of sustainability, this is important, all right? Because we just need 20 watts, guys. What's going on? Our brain is amazing, because we need 20 watts in terms of processing. Everything is going on around our neurons and around our synaptic connections. So we will see the artificial neural networks, the capabilities and its limitation. I have already introduced the artificial neural networks with an input layer, with hidden layer, and with output layer. So artificial neural networks, and we have to see its capabilities, what they can do, and their limitations. So artificial neural networks are structured in layered topologies, which can be feed-forward, convolutional, or recurrent. For instance, the convolutional neural network, as the doctor which spoke before me have said, with the practice of max pooling, they have to analyze the images, and those have an applicability in medicine, which is huge, because convolutional neural network can analyze images in radiology. There is something in a positive way crazy. And basically, what is going on here with artificial neural networks? They have a lot of capabilities, such as the convolutional neural networks, which can literally see. So they have a vision, machines who have a vision. And as I said, in the medicine world, there is a huge applicability, because they can see radiology and they can analyze, as the doctor previously said, they can analyze images in real time, even better than human. So they have layered topologies, which can be feed-forward, convolutional, recent structures, forming architectural foundation of what is the modern artificial intelligence, because the modern AI talks about artificial neural network, which are going to make an artificial synapses. Then we have learning mechanisms. So this is good, because we have learning mechanism, and they have gradient descent and backpropagation algorithms. So what is backpropagation? Backpropagation is the system which allows a neural network to learn by its own. And this is huge, because the concept of backpropagation was introduced by the godfather of artificial intelligence, which is Geoffrey Hinton. So learning mechanism, it's one of the positive aspects. It's one of the capabilities of artificial neural network. Now we'll talk about the main limitations, like the energy demand, because obviously AI is applied in the whole world, so it costs a lot in terms of data center and energy demand of servers which have to sustain artificial intelligence. So there is a high power consumption during the training and interference phases, which is going to require significant computational resources. This is an important aspect. It's going to require significant computational resources, which are very, very important. And then we have data requirements, which are intensive data, the needs for an effective learning, as the slide says. And the point is that they need to achieve accuracy. And in order to achieve accuracy, they are going to need millions of examples. So that is why the energy demands will increase, because in an algorithm, we have the training phase, then we have the test phase. And in the training phase, we need to train an algorithm, and we need the energy in order to train these algorithms, all right? So we're gonna have synapses, comparisons, ER with biological versus artificial. So before unifying biological synapses with biological components with artificial components, we are going to see their comparison. So we are going to see the positive aspects of those components and the negative aspects of those components. So biological synapses adjust transmission probability through a practice which is called ion channel regulation, which have mechanisms like LTP, which is the long-term potentiation, and the long-term depression, there is LTD. So here there is the biological synapses. And there is a neurotransmitter release. There is, according to neuroscientists and engineers in the whole world and in this sector, there is something incredible. It is something incredible because it is something that it allows people to process information without the much bad consumption. Then we're going to have artificial synapses, which is the scalar weight in matrices and mathematical operations. And the artificial synapses, as I said, with an input layer, with hidden layers, and with output layer, they have this predetermined architecture. So they have an amazing and extraordinary computational capacity, but they consume a lot. That is why there is the emergence from an engineering perspective of integrated system which are adaptive hardware with neuromorphic computing. There is important with an hybrid learning mechanism. So with biological components such as living brain cells and mother card, which is an hardware. And this is a dynamic reconfiguration. So what is synthetic biological intelligence? Synthetic biological intelligence, it is something that is going to unify biological components and artificial components, and it involves in closed loop feedback. And those are closed loop feedback because are going to be feedback also in a way, we could say, of the testing phase of the algorithm logic, that we are going to check between real neurons and computational interface. And this is not wholly biomimicry, but this is biology. This is biology in the loop, in a computer science loop. So this is a union between computer science and biology, and it offers continuous learning by consuming less, because one of the most innovative factors in terms of a synthetic biological intelligence, which is an intelligence that has artificial components and also has biological components, it is going to be a biophysical efficiency, because there are also physical limitations in terms of the step that a machine has to take in order to think. There are biophysical limitations and physical limitations from a physical perspective, but with this biophysical efficiency of biological computers, which were released just a couple of months ago, we have an efficiency which brings not only artificial intelligence, which brings intelligence to the next level. This is one of the most important things because it tests real neurons, real living brain cells. This is crazy. Real living brain cells and computational interfaces with digital systems for input and output, which are two of the most impressive component in neural networks, which could be artificial neural networks or biological neural networks. As we said, they have a closed loop feedback because they have a continuous adapting cycle. And another important thing is that this is an emergent intelligence. This is a new form of intelligence, which is not only human, which is not only artificial, but this synthetic is the union between biological components and artificial components. And this is an engineering reality. It's not just a science fiction as it could have been a decade or a couple of decades ago. It's something which is real because there is Dish Brain and CL1, which is the first biological computer that was released from a startup in Melbourne in Australia a couple of months ago. So it was created by Critical Labs and is going to use 800,000, almost a million of human neurons, which have grown in a multi-electrode array. There is called MEA, that was trained by electrical simulation, and neurons have learned in this specific example to play in a simulated Pong environment. So this was enthusiastic, and this has led CL1, the first biological computer, to have a modular neurosilicon device where every chip of that biological computer is a so-called bioprocessor. There is something completely new, such as this concept of synthetic biological intelligence. It is something extremely new. There is going to analyze the future of intelligence itself. There was the Pong training, so with the neurons who have learned to play simultaneously via Pong feedback. And then the CL1 creation, as I said, the modular neurosilicon device bioprocessor, and the digital integration, the real-time neural computation in a digital workflow. So CL1 architecture and operation. Let's dig into this first biological computer, which I encourage you guys to go and take a look at this first biological computer because it's something amazing. So if you see a picture, just look out up in the internet. If you see a picture of this hardware, of this biological computer, you are going to see the living brain cells in this hardware, similarly to this image, which was made obviously by AI, by the power of generative adversarial network that artificial intelligence has. So the CL1 architecture is the following. Has acculturated neurons on the media interface with a so-called FPGA logic. So there is a kind of training which is a spike training. There is no training like simple artificial neural network, but it is a training that is going to encode stimuli inputs. And this is going to make it possible what is so-called from neuroscientists, because in this field, there are involved not only as a teacher, as instructor, as professor, as engineers, as researchers, as computer scientists, not only are involved in this field, but also neuroscientists. Also neuroscientists, because we are literally talking about a new form of intelligence. There is no biological, it's not artificial, it's synthetic. It's a union between biological and artificial intelligence by taking into account the positive aspects of biological efficiency and the positive aspects of artificial processing, which is huge. So neural response captured via electrocodes and analyzed by machine learning, which, as you all know, is a subset of artificial intelligence. Then we're gonna have a continuous closed loop feedback reinforcement. What it does mean? So basically, A continuous closed-loop feedback reinforcement, it means basically that in an unsupervised way, this synthetic biological intelligence can learn in an efficient way and can literally behave. So it's going to form a behavior because it's going to have perceptions, it's going to feel emotions, which is something that as a humans we all do. There is who feel stronger emotions and who doesn't, but basically we all feel that. And this is going to feel a real behavior, this form of synthetic biological intelligence, and it is the next phase of AI. Now we will see one crazy graph. So this crazy graph basically shows us how human brain is efficient. It is extremely efficient because here we see that human brains is going to use only 20 watt for performing xScale operations. Meanwhile, GPT-3, which is amazing, but GPT-3 per hour, he's going to use around 1,000 more or even 10,000 more the energy that the biological components allow the CL1 rack, which has 30 chips to run. Because here in this graph, we have the human brain, as I said, only 20 watt, right? Then we have the CL1, which has a power consumption of 1,000 watt. And maybe why? Because the CL1 is the first form of synthetic biological intelligence. There is the union between artificial intelligence and biological components. Then we have GPT-3, which is only artificial intelligence, which has roughly 1,470,000 of watt in terms of power consumptions. So that is why synthetic biological intelligence is the future of intelligence, and it is the future of humanity in a way, because when you can have an intelligence which is going to consume less, everybody is going to be interested in it. Because one of the biggest problems, one of the biggest barriers in terms of entry in those kind of markets is also the power consumptions. But if you use human brain living cells, it has been demonstrated by scientists, and this is going on right now, that there is going to be much more efficiency. So why efficiency matters? It matters, as we all know, to have a climate responsible computing, because obviously if it consumes a lot of watts, there is going to be a problem. There is going to be a problem in terms of climate, because it's going to waste a lot of energy. I am a scientist. I don't care about left, right, and so on. I came up only with scientific conclusion, all right? So if it's a scientific truth that we can protect the climate with this new form of intelligence, there is also more efficient to process information with synthetic biological intelligence. This makes me think that it's one hint more for which it can be the future. So there are also edge AI applications which have a local processing without a so-called cloud dependencies. I would love to go into every details of cloud dependencies and so on, but I should speak for 10 hours, and I really hope that you're enjoying this, because it's something which is going to talk about not only the future of economies with AI, but the future of intelligence itself. There is not only human, not only artificial, but synthetic. And also in terms of robotic and neuroprosthetic, there is a system which is going to be much more efficient with the synthetic biological intelligence rather than with AI, and is going to overcome what we know as physical limitations like latency constraints and so on that we have with hardware that we have nowadays. That is why with the biological computer, with the quantum computing, the concept of intelligence itself will grow even more. So this is just the beginning. This is just the beginning of AI, which in my opinion is overestimated in the short term, but is underestimated in the long term, because we will need AI. That's the truth. Like in anything that we do, we are going to need AI. I am going to live with AI, for God's willing, always, every day. That's it. So that is why in the future will always be exponentially more important. We are going to see synaptic plasticity and real-time learning with the neurons that are continuously going to modify their synaptic way with a practice that is called calcium-driven cadences and the receptor redistribution. And in a synthetic biological intelligence systems, those are going to translate in a new way of learning. So a real-time learning in an unsupervised way with pre-programmed way and fixed datasets. So one of the most important things here is not only the real-time learning, but is why there is this real-time learning. And the most important component of why there is this real-time learning is the receptor redistribution. So physical changes in a synapses with these receptors that are going to physically, because we are also talking about physics and neuroscience. We are not just talking about computer science, we are talking about physics and neuroscience. And with the union of those, we can have a synthetic biological intelligence with this synaptic plasticity, which is going to form a new behavior, which can compute more, also because it's more efficient. And we will introduce also a concept which is important here of the spiking neural networks. So we spoke about the biological neural networks, the artificial neural networks, but we can talk about something which is even more efficient to form a new form of intelligence. There is the synthetic biological intelligence, and those are the spiking neural networks, because the spiking neural networks are going to process information through a discrete spy-likes, and they have an amazing encoding which is going to use a spike timing dependent plasticity, which I encourage all of you to look at, because thanks to this spike timing dependent plasticity, what we have is a spike generation. So those are neurons which are going to fire a discrete action potentials when a membrane in our brain, it exceed their threshold, because we also have limits. I myself have many limits, but thanks to this spike generation of these spiking neural networks, we can prevent those and we can move forward always more with this new concept of SBA, synthetic biological intelligence, which also has a temporal encoding where the information is encoded in the timing and in a new kind of pattern, and it does not have any more continuous values, because it will be and it is like a real behavior, because the biological computers are already in the market, and their price is estimated to be around 30K, something like that. They are already in the market, and they have a STDP learning. So synaptic weights will adjust how, by basing themselves on a relative time pre and after the spikes that we have spoke about here. So the spiking synapses. Then we're going to have the hybrid integration, where biological neurons and artificial spiking neural networks will combine together for having an aware cognition which will form a new kind of behavior. So we have spoke about the artificial synapses, which is going to use mathematical operations and optimize for specific tasks. The biological synapses, which is energy efficient. And now we have to have hybrid results, which is the future of intelligence and the future of humanity itself, with a lower energy consumptions. That is crucial, and it is adaptive. It's adaptive to novel, to complete brand new situations. Now, we go into a point that I really like. So, which is one question. Honestly, I do not know the answer. I don't think there is possible to have an artificial consciousness because I personally think the Holy God can create consciousness, but artificial consciousness is something which is the second step for many scientists, for many neuroscientists, for many engineers after artificial intelligence. Because we all know that a machine can be intelligent, but do we know if a machine can be conscious? As I said, one of the greatest in AI, which is Geoffrey Hinton, the godfather of AI, has said something about it, and many scientists also have said, and the way they were talking, it made me think that for them, there is the possibility of a machine being conscious. And in my personal view, there is a strong possibility of we all kind of believing that a machine seems conscious, because already the Turing test, which was overcome by GPT 4.5 with 73% of accuracy, as one specific goal, so making us believe that a machine is human. So the perception of artificial consciousness for me is possible. Artificial consciousness itself for me is not possible. But what scientists, neuroscientists, and engineers says, they think that with the synthetic biological intelligence, with the real living brain cells combined with artificial neural networks, they think there is possible. But it's not only going to be a physical problem, an engineering in terms of computing problem, and a biological problem. It's going to be also a philosophical problem, because in order to see whether if a machine is intelligent or not, we have the Turing test. But how do we see if a machine is conscious? Someone says a Turing test, which is more advanced. Other people say the mirror test. There is something similar at putting a machine also in a metaphoric way in front of a mirror and see how the recognitions would be. But it's almost impossible to determine that a machine can be conscious. So because we could say why he's conscious, but before saying why he's conscious, we should determine the definition of consciousness. So we have an emergent connection with synthetic minds, which, as I said, is an hybrid system of neural tissues and computations. And this leaves pitch to an emergent connection. So to something which is going to be completely new thanks to this biological integration and hybrid architecture. Now, there is also going to be the ethic perspective, because as a scientist, we have also to think about ethics, since we are dealing with people that have emotions, just like each one of us that have a moral and that are going to shape ethics. So the questions which are going to be made from an ethical perspective to synthetic biological intelligence are: do biohybrid systems possess ethical status? And can learning system cross into sentences? So there is the potential of an emergent consciousness, which is going to be completely new, and scientists are thinking, does it have rights? Scientists are posing also ethical questions. So when it comes to that's what I want to say, and that's what I'll say. When it comes to a new form of intelligence, whether if it's artificial or synthetic, there are going to be involved everybody: philosopher, engineers, lawyers, people who comes from many sectors, biologists, neuroscientists, everybody, because intelligence is something which is going to be the first step of anything that we do. That is why there is going to be this ethics, this ethical side, and this ethical sphere. Now, another question, as I said, is should lab-grown neurons have data rights? Which is a crazy question. But it is a question which is not anymore something that is going to be representing science fiction, but there is going to be representing reality. Now, what is the future of intelligence? The future of intelligence is going to be the union between biology and hardware. So, in my personal view, as science continues to grow, the future of and the evolution of intelligence will not be just the biological intelligence. There is the natural evolution, as one of my colleagues said. Indeed, I really liked the first presentation because he was talking about the biological evolution of humankind and history. And he went to the present, and I am going to the future also with synthetic intelligence. There is going to be the future of not only artificial intelligence, but the future of intelligence. Because there won't just be human thinking, there won't just be human thinking with machines, but there will be a new form of intelligence. There is going to be a much more energy efficient one, and according to many scientists also, and perhaps conscious, synthetic biological intelligence, a new form of intelligence which will come from the union of us with machines. Anyway, I really enjoyed talking to you about this new form of intelligence and this new form of AI. And I'm willing to take any questions whatsoever, and let's stay in touch in order to keep studying and keep learning, because we are always learning and we are always studying, as you all know, and keep making networks to make the humanity progress, because we are all here as individual, and in conferences like this, we are giving our contribution to share knowledge. That is one of the most precious things in terms of studying. So thank you, and if anyone has any question, I am willing to answer. Thank you very much for listening.
Thank you, Doctor. A wonderful presentation. Congratulations, was a treat. Now tell me, myself, Dana, how can I use this? How can I learn? How can I use the AI learning for me?
All right. So how can you use the AI learning for you? Basically, in this, thank you for saying that this was a wonderful presentation, really. And in your case, basically, in the future, this new form of synthetic biological intelligence will be very, very important because it will increase the applicability of AI. So you already nowadays can use AI with AI agents, which I personally know how to implement, and I help many people from various sectors, and I could help anyone who is willing to be helped with AI. But the main concept of synthetic biological intelligence is that it will be an AI, but more powerful. Why? Because, for instance, if you want to use for your personal life an AI to generate content, it will consume power, all right? So it will consume power, and you can generate a certain amount of content based on how much power it consumes, right? But in the future, with the synthetic biological intelligence, it will use less power, so you can generate more content. So in anything that you do with AI agents, with generating content, with the medical stuff, with having lectures with your digital clone, in anything that you do, this will be empowered because it will consume less energy. So you will just do more, and everybody would be able to do more in anything that we do by implementing artificial intelligence in our lives.
It is biological intelligence. Is it available right now?
Yes, there is the CL1, there is the first computer. There has been released by Cortical Labs on March. I don't remember exactly the day, but it was released on March. And with this computer, there is a less consuming in terms of power
How do you
of
call it?
system.
Cortical? What's the
Cortical
name of it?
Labs. Cortical Labs. If I have spelled correctly, it was Cortical Labs. And they have released the first biological computer. But what I'm trying to say is that, I mean, even if you don't buy the first biological computer, you can already use AI, as my colleagues said, with AI agents and much more. And this is good. And another thing, in the future, with this new form of intelligence and synthetic biological intelligence, everything that you will do now and that everybody does now with AI, it will be even better because there will be less energy to be consumed. So it will be much better and also more sustainable.
What I would like for this biological or artificial intelligence to help us be happy. Wouldn't that be
Yeah,
nice?
it
I think
it can be very, very nice. You know,
to
it can
find
be
a
very nice.
solution to give to get a program to give us boost of happiness.
It can
You
be
know
very
that
nice.
that is at the base of treating post-traumatic stress syndrome, which I've
Yeah.
seen to children victims of violence in Africa. So that is my dream that one of you guys will put together a program in biological intelligence to give boost of happiness.
Look,
Thank
look,
you,
look.
Antonio.
It
Grazie.
it could be very nice, and you are welcome. You are more than welcome, and prego, as we say in Italian. And thanks everybody for listening to me. If there is anyone else who has some questions, I will be happy to
Io
answer.
parlo italiano perché ho abitato a Monaco.
Complimenti,
I have
bravo.
just one question for Antonio, if it's possible.
Yeah, please.
Okay, Antonio, thank you very much for your very interesting presentation, first of all.
Thank
And
you.
second, I would like to know, in your opinion, which is the suggestion that you give to a biological researcher that now is finishing a degree. So how can he is evolving this profession thanks to the AI opportunities?
Well, yeah. Thanks for your question. So it's not only for a biological person who has just come out from the college and who is going to make his career. So he is going to make network to work hard, but it's for everybody. So I strongly suggest to just about everybody from any kind of sector to implement AI skills and become an specialist of AI, which seems hard, but it's not actually that hard. You know, with months of hard work, I genuinely believe that everybody could become an expert in AI. And personally, getting back to your question, from a biologist, it is very important to be in touch with the people who are working in this field, in the field of CBA, of synthetic biological intelligence, because from a technical perspective, it is going to be the future. Why? It is going to be the future since countries and companies are interested everybody in spending less, and everybody is interested not only in spending less, but also in implementing AI. So as we say, 2 + 2 = 4. Synthetic biological intelligence, it could be the future. And as a biologist, I would see myself as a pioneer of this, because when the market is not saturated, I could be extremely helpful to help countries and to help companies of any kind, like any countries with no limits, anyone who needs help, and also any company who needs help with no limits to implement this synthetic biological intelligence, which will make consume less. So if I was just come out from the college as a biologist, I would be in touch with the people who are working on this, and I would come up to them with the new ideas and trying to make them a good impressions, and trying to make as much network as I can, and start working for them in a good way. That's what I would do, because in the next decade, this is the future. As my professor in Lewis of AI said, AI is overestimated in the short term, but is underestimated in the future, because in the future, even the future of televisions, for me, it will be done with AI, thanks to the power of generative adversarial network. So it's something, that's what I would suggest to these biologists, to be in touch with people who are working on this, and to be a pioneer on this. So to become an AI specialist and biologist at the same time, young, who is willing to work, who has energy, and working on this. That's pretty much it. Then maybe from a money perspective, in the short term, he's not that much, but in the long term, it will be. Anyone can make his own choices, and I am passionate about both of the sides, about selling AI to professionals, to organizations, and also about dig into what the future of AI is going to be. And that's pretty much it. Thanks for your question.
Thank you for sharing your perspective, Antonio. Very interesting. Thank you.
You're welcome, and you are welcome, and prego.
Prego to you.
I have another question. You said something about television, the future of television, because adverse something?
Yeah, so generative adversarial networks, those are the neural networks which are able to generate content, right? So those neural networks can literally generate content because they have a generative artificial neural network that can generate content based on the real contents that we give them, and a discriminative neural network which will distinguish what is the content that was generated by AI and the real content. And those are algorithms which are going to generate content, video, images, and audio also. And soon there will be the first movie which is completely released by AI, with actors who have never really existed. And in the future, with more powerful hardware, such as the quantum computing or the biological computer, there could be entire TV series which are generated by AI in a few minutes. So it will be just about crazy in a positive way also, in terms of generating content. Also because if a television owner has to pay a good person with a good aspect to talk about the Meteo, all right, is going to be a good thing, but what if an AI clone, which is completely generated by AI, can do that for that television owner? Is going to be costing less. So it's going to be that the choice. And that's why the future of television, in my view, is also with AI.
Do you think they already use AI to create content and fake videos and stuff?
Oh, yes, I do. 100%. Yeah, they. Why? Because it's like having the cars, all right, and asking a question like, do you think that they already use the cars to exceed the speed limit? Idealistically, it would be better if no one does it, but yes, they do. All right. So, and the main point is that only whoever has the code can literally prove that that content was generated by AI.
You
So,
have
yeah,
code you can prove by a code?
yeah.
Can you
Only
teach me how to prove that? Can you teach me?
for sure. Yeah.
Oh my
I
God,
I
we'll
could
all
be
become
able.
your students. Are you gonna teach us how to prove, how to detect the code of fake? That will really change the world of
I
news.
know. I
That's
know. I
fantastic.
know.
That's wonderful.
Thank you.
Antonio, I want to invite you. Uh, 12th of October is my birthday on the 13th, but on the 12th we have a meeting in New York. You have
All
time
right.
to prepare. Please come. Yes?
All right. I see what I can do. Thank you for the invitation. Thank you very
Grazie.
much. Thank you very much. Prego, and thank you
And
with all my heart to all of you. God bless you all.
be very happy and see you tomorrow for the panel.
All right. All right. Thank you. Thank you very much.
And now we have the honor to invite a beautiful young researcher. And please, if you can introduce the researcher, Dr. Abiola Olomola.
Our next speaker is Mrs. Abiola Olomola. Mrs. Abiola is an accomplished IT, GRC, and cybersecurity leader based in Dubai, UAE. With 2 decades of experience, she spearheads the development and implementation of robust IT frameworks that align technology strategies with business objectives while mitigating cybersecurity and operational risks. Her expertise spans strategic IT governance, cloud security, AI risk management, and regulatory compliance with standards such as ISO 27001, NIST GDPR, and PCI DSS. Her innovative approach and strategic leadership have earned her numerous prestigious awards, including the Most Strategic IT Leader of the Year award from Middle East Gen AI and Analytics Awards, the Leader in IT Governance, Risk and Compliance Award from Global Women Leadership Awards, and recognition as one of the top 5 remarkable women making an impact by CIO today. She has also been acknowledged by the CXO Time, Empire Magazine, and Impact Leadership Awards for her transformative contributions in IT. Abiola holds a Master of Science in Information Technology and a Bachelor of Science in Computer Engineering. As an active member of IEEE, ISACA, EC Council, and PMI, she continues to drive organizational excellence and inspire industry-wide advancements in IT, GRC, and cybersecurity. Please join me in welcoming our speaker, Mrs. Sabiola.
Hi everyone. Thank you, Kiran, so much for the introduction. And it's been a pleasure and an honor being in this wonderful cloud of intellectuals. I've learned a couple of great ideas, a couple of great things on this presentation. So I'll be sharing my screen right now, and we're ready to go.
Have you shared your screen?
Yes.
Yeah, got it.
All right, so my name is Abiola Olomola, and I'll be, I've been hearing a couple of different scenarios within AI, neural networks, and all that. So it's very good that we have this new technology in place, very, very essential. It makes our lives easier and it makes us do our work efficiently. It introduces a whole new ball game of how we can effectively and efficiently make operations, seamless with little and no intervention from human. Now, you bear with me that if we have a new technology, back in the days where we're talking about cloud computing, we're talking about cryptocurrency, different innovations and different ideas that come on board. But agree with me that if we don't put the best practice in place, the best policies in place, putting structures in place, then any risk, because with any new technology, there are a couple of inherent risk around it. So any risk around that, if you don't put enough structure, enough policy in place or practices in place, to secure the entire infrastructure, to secure the entire application, things might go wrong, right? So it's not, we don't want things to go wrong. Okay, so I think I don't need to go into who I am. Karen had made a very good justice to that. So my name is Abiola. I have a master's degree, have a bachelor's degree, and have a couple of certifications. I currently completed my leadership and management training in Harvard Business School, and I have gotten a couple of awards. So how do we make AI both powerful and also trustworthy? So we've been talking about the powerful part of it, or what AI can do, the great thing AI can do, all the neural networks, all the new advances we're doing, how to combine the entire human power with computing, capabilities. Now, how do we make sure that it's trustworthy? Okay, so we just don't want to give the entire whole world or our entire processes, to a machine in quotes, and we don't put enough structures in place, or we don't put enough safeguard in place, policies in place to be able to guide that. So we're talking about a couple of definitions. So we all know the definition, so I might not really go into that. Then we'll talk about why governance is important, because governance is important in every structure, even if it's political structure, economic structure, the business world, the academics world. Governance is very, very important. Even in our homes, right? We all understand, the structure of governance. Then we'll talk about a couple of frameworks that we've been seeing from EU, from US, ISO frameworks and all that. Then a couple of recommendations. So definition, I'm sure different presenters have already done this justice today. So artificial intelligence system performing tasks requiring human intelligence, and which requires definitely a lot of data, right? The core techniques, machine learning, deep learning, NLP, reinforcement learning, and all the applications that we can do, or how we can apply all these techniques, in what we do. So moving on, so what's the importance of AI governance? So this is a $100 billion plus investment. So all over the world, total, from the experts in the world, US, the UK, the China, all these countries are globally, in total, we have a global AI investment exceeding over $100 billion on an annual basis. So that shows that it's a huge investment, and organization, entities, countries are trying to investing money for we can get economical value from it. So AI poses risk such as algorithmic bias, privacy breaches, and systematic vulnerability. So we have a couple of risks around that. So even though we've investment a lot of money in it, there are a couple of biases, a couple of privacy issues that we have around that. Okay, and another importance is the alignment imperative. So we need to make sure that we have effective governance that ensures AI aligns with societal values, human rights, legal obligation, which is very, very important, okay? So we understand what AI can do. We understand the extent at which what AI can do, but we want to make sure that it's not infringing on any human rights. It's not infringing on your privacy. It doesn't have any, it's not going to, lead to any legal issues in future. Okay. So this is another one that has to do with big tech companies, specifically for big tech companies. It has about $300 billion, projected. So this is in future, projected for 2025 and beyond, okay? And the US private investment, they've invested a couple of, amounts within the AI landscape. So what are key stakeholders in this? So we have the government, so enacting regulations and national AI strategy. So most of the time we see all these regulations that are coming on board is governments that actually enact them, right? So the likes of the EU AI Act, the likes of the US AI, a couple of documents that have been released by the US government. Then we also have industries that are developing AI products that implement corporate governance and ethics policies. So now, kind of is the government that is responsible to be able to, enact regulations or regulations in place, okay? While we have the industries that develop the AI products, the likes of OpenAI and the rest, okay, and make sure that they have a couple of corporate governance in place and ethics, ethics policies. Then we have the civil society and the NGOs that advocate for transparency. So they've seen a couple of risks around this AI. So we have a whole lot of NGOs and civil societies that are coming up advocating for transparency. So down the line, while I'll be showing us the regulations, the center point within most of the regulation we'll be talking about has to do with transparency. So what do we know? How do we know the algorithm that you say this AI is going to execute this task is doing it the way it's expected to do it? How do we understand that all the privacy is complying with a couple of privacy laws like the GDPR and co and the California Consumer Protection Act? So also we have the academia that conducts research on and on and on, research about AI, cloud, AI, neural networks and the likes. Then we now have the standards bodies like the likes of the IEEE, ISO and the likes that establish technical and socio-technical standards for trustworthy AI. So the first one we'll be talking about is the OECD AI principle. So that was adopted in 2029. It's kind of like the first intergovernmental standard. It has a couple of 5 value-based principles, a couple of recommendations, and it was updated last year. So now the OECD principle talks about the inclusive growth, sustainable and development and well-being. So it talks about how AI should benefit people and the planet by driving inclusive growth. It talks about human-centered value. So remember in my first presentation, majority of these policies or regulation is really centered about human rights. It's centered about transparency, accountability. So you probably hear me more saying almost the same value across board. Then transparency, there should be transparency and responsible disclosure around AI systems to ensure that people understand the outcome, okay? There's also something called, we don't want to over-rely on AI. So even though AI, you're automating your entire processes, end-to-end processes, and AI is executing that, we all know that agentic AI is coming on board, or it's even on board, right? Where it's zero human intervention. So in that case, you want to put some stopgap or some controls in place to ensure that even though it's executing everything end to end, you want to do a couple of stop check, a human coming to check at different processes. Is this the expected outcome that is required? So those are the controls that you can put in, that we can put in place to ensure that any inherent risk doesn't crystallize. Then we have robustness and security, safety. So all AI systems must function in a robust, secure, and safe way throughout their life cycle. Then we have the accountability and audit. So the organizations must be accountable, okay? So we have questions like, I was in a conference like almost a month ago that we were asking that, oh, how do you do it? Infringement rights, right? So probably you ask the AI to, do a couple of images, and probably he copied an image that has a, a trademark, something that is trademark, right? That has there's an intellectual property. So how do you address that? So those are the things that we need to be addressed within the policy. Okay, so we now have the EU AI Act. It's the first comprehensive legal framework. So this is like the framework where organizations in the EU, organizations that either have operations in the EU, or where your AI software is being used by EU citizen, okay, or where you are importer. An importer is someone that procures the AI application, okay. So the AI Act, the EU AI Act was enacted, and it's the first comprehensive legal framework for AI worldwide. It aims to foster trustworthy AI. So continue to hear the word trustworthy through a risk-based approach. So what they did is, for any AI system, they've categorized them into like 4 different sections. So we have the lowest one is the low risk. Then from there we have the medium risk, then we have the high risk, and we have the one where it's unacceptable. So what that means that under no circumstances should you build an AI to be able to do such capabilities. So that is how the EU AI be able to categorize all the systems. So the minimal risk or the low risk has to do with voluntary code of conduct. The limited risk has to do with transparency obligations. Then the high risk has to do with strict conformity assessment. Then unacceptable risk means you are not, under no circumstances, all those AI applications. So application that has to do with infringing on human rights, that has to do with biometrics, doing a thorough scan of biometrics, checking people's social security cards. So those type of applications are not accepted. Okay, so the tiered model ensures regulatory bodies match the potential harm. So anything that has to do with that is classified under the high risk AI, there has to be a conformity assessment. Data, there has to be something called data assessment. So making sure that all the data being used in the entire AI system is thoroughly assessed, thoroughly categorized. There has to be risk assessment, risk management. Like you need to actually document, do something called risk assessment, document all the risk prevalence, then assess the risk. Okay, once the risks have been assessed, so you've probably identified all the risks. So a major risk can be data privacy issues. Another major risk can be hallucination, for example. Okay, so once those risks are identified, okay, so you now categorize the risk. So is this a high risk, or is this a medium risk, or is this a low risk? Now, based on the classification of risk, based on the impact and the probability of the risk, then you now infer controls. What controls do we need to put in place to be able to mitigate this risk? Okay, then you need to make sure that there's human oversight in place. So a human has to actually do some checks within different categories, and all those needs to be documented based on the EU AI Act. So all those risk assessment, data assessments needs to be documented. So whenever the regulators come to check that the organization is complying, so they need to make sure that all those documents are in place. And then at the end of the day, they can probably do a stamp for the organization that then your application is AI certified. So it's called CE marking, so that you've met all the conformity requirements. So moving on, we have key obligations and requirements. So for the EU, for the high risk AI system, okay, I think I've already discussed this in the previous slide, but it's fine. Implement a robust risk management, ensure data quality, also maintain human oversight and provide detailed documentation, very important. Then transparency requirement, the users must be informed when interacting with AI. So with your high risk system, so remember we mentioned earlier, in the unacceptable, you're not even allowed to be able to develop AI systems that will infringe human rights, right? So for the high risk systems, has to do with probably if you are building an application it's like a scoring application for academics. Okay, you are building an application where it scores you students. Another example of a high risk based on what we have documented in the EU AI is employment. Any AI system that has to do with employment, where the candidate is being scanned, like, oh, this candidate fits this requirement or not, is a high risk AI system. Okay, so like that, those are examples of high risk AI systems. So innovation support, make sure that, so in this case, the regulators, based on the EU AI Act, regulators need to have sandbox in place. So I think mistaken by, I think 2 years after the regulation is being enforced, each country within the EU, they need to provide sandboxes for testing of the AI. When you need to develop your AI, so they need to test, your AI application, especially for SMEs. The enforcement, now for the unacceptable risk, okay, if there's a case where an AI is built around that has to do with any infringement of human rights, the company is liable to pay fine up to 35 million euros, or 7% of the global annual turnover, for serious violations. Okay, so they are serious as that. For the iris is about, I think, 15 million euros, okay, or 3% of their global annual turnover. And for a medium risk is about 7 million euros. So, or 1% of their global annual. So what are the timeline that we have in for the EU AI Act? So 1st of August 2024, that was when the EU AI enter into force. Then on the 2nd of February, sorry, 1st of August 2024 was when AI enters into force. Then 2nd of February 2025, it's when the prohibition and AI literacy and enforcement comes into effective. Now, 2nd of August 2025, that's when governance rules for general purpose AI starts, okay? And now 2026 August is when they start enforcing that organization needs to be compliant. So which means right from now up until 2nd of August 2026, organization has the right to be able to put all these measures in place. So they need to do, this AI that they've developed or already operational. What kind of risk is this? Does it fall under the medium risk? Does it fall under the high risk? Or it's not even acceptable, okay? So is this time that organization needs to start putting measures in place, depending on the requirements for each risk level of application. They need to start documenting, putting enough documentation in place. So when it comes 2nd of August 2026, the regulator can easily come in to do a check and confirm that organizations are complying. August 2nd, 2027, then we have extended transition period for high-risk embedded products. So this is not a cast in stone timeline based on what we had from EU, okay? It could change, so constantly they will start also be bringing up clarification, because there are a couple of gray areas within the EU AI Act that needs some clarification, and organization must map their AI system to risk categories and establish compliance frameworks. Policymakers need to refine sector-specific guidance for harmonized global AI. So let's look at the NIST. So we move from so actually dwell more in the EU AI Act because it's actually the regulation that enforces, and it has in case the organization doesn't conform, it has there's a fine attached to it, so it's enforceable. We have the NIST AI risk management framework. It has to do with mapping, identifying, and assessing the AI risk. So this specifically talks about how do you manage the risk within AI. So that's what this framework is all about. So it has to do with mapping and identifying and assessing the AI risk, measuring, so analyzing the risk, or what kind of risk is it a high risk, is it a medium risk, is it a low risk, based on the probability and the impact of the risk. Then implements risk control. So if the risk, for example, is a low risk and the impact to the organization is not high, the organization can actually choose to accept the risk. So depending on the organization's risk appetite, okay, that's how they can implement risk. And probably if it's a risk, they can transfer them. So, we don't want our organization to do it. Let's outsource it, the risk, so they can actually transfer the risk or actually put measures in place to mitigate the risk. Then improve, enhancing processes continuously, then also establishing governance structure. So that's what, so this framework actually deals with how you manage risk within your AI application. So we have UNESCO ethics recommendations. So it has to do with safety and privacy throughout your AI lifecycle. We need to make sure, we all know that AI, the thing driving AI is the amount of data you feed it, right? So, and based on data, you also need to make sure that there's no infringement to people's privacy. So within your entire AI, so that is why we have data quality management within, the AI assessments. Throughout the AI lifecycle, multi-stakeholder approach, which means, so it shouldn't just be probably your engineering department or your AI department that is involved. So you need to involve a couple of stakeholders team to be able to interpret the correct regulation that the organization is resides in. We have your governance team that are able to confirm that in case anything goes wrong, this is what is going to happen to the organization. These are the hits, or this is what is going to affect our bottom line. You have your GLC team, governance, risk and compliance team. You have your IT. Okay, we also have your data warehouse team also needs to be involved. So it's a multi-stakeholder approach where you involve a couple of your stakeholders to be able to be involved in the process. And this, was adopted November 2021. So still on the UNESCO recommendation. So what UNESCO is saying is that number one, do no harm, which is very important, and it's kind of reflected what we talked about in the EU AI Act that has to say there are some AI application that it shouldn't even be designed, right, and classify that under the unacceptable risk. So do no harm, there has to be safety, security, and privacy, multi-stakeholder governance, then responsibility. Then we have the IEEE AI ethics standards that has to do with global standards, socio-technical guidance for AI ethics, certify AIED program, how you do certification for your autonomous system, then give open guidance for a trustworthy AI. So in detail, so it provides a comprehensive guidance for trustworthy true global socio-technical standards that addresses both the technical implementation and the social impact consideration. Now, looking at this life cycle coverage, the standard covers the entire AI life cycles from the design. So there's something called security by design, privacy by design, so governance by design. So what that means is that you shouldn't wait until when you want to deploy your AI. That's when you need to start thinking of, oh, what are the security things I need to put in place, or what are the privacy requirements I need to put in place, right? So you need to start from the point where you're conceptualizing the idea of the AI. So all those factors need to be considered: your security, your governance, everything needs to be factored, also your controls. So everything needs to be factored at the point of conceptualizing, the idea. Then free access. So IEEE actually offers a free access program to, provide support, industry implementation, policy developments, making sure all this come into one place in a very good place. We have a WES AI Governance Alliance where we have the cross-sector collaboration. So people, different organizations, different countries and different sectors, they come in together to be able to collaborate, doing research and policy guidance, and also confirming best practices, all the best practices that needs to be in place, and also strengthening the governance framework. So it focuses on skills development, how we can share resources. So this is more like, oh, let me know what you're doing around AI within your sector, and let's come together to collaborate. So it's more like that. And let's see what technical controls we need to put in place to be able to self-regulate AI within the AI framework or within the AI landscape. Then we have the CSA AI model risk management. So what this does is that it looks at the risk. So this actually focuses on the risk, similar to the one that I talked about in the ISO one. It looks at risk monitoring, oversight, whose responsibility is it to be able to look at the risk within the AI system, the risk mitigation, the risk measurements, the risk, identification. Then we have the ISO IEC 42001 AI management. So this ISO 42001, is the entire framework for AI management. Okay. So what it does is that it looks at it's kind of the first AI management standard. So this is more like a standard, right? That is established in 2023 for global governance. So it looks at also data management focus, the quality of your data, how is it? How are you establishing data owners? How are you establishing data stewards? Okay, in case the customer said, "Oh, I want my data to be deleted," or is there a process in place? At the point of getting this data from the customer, are they informed that, oh, this system is data you're giving us? You need to put a couple of information. The users need to know that you're collecting the data and they have the right that data should be deleted. So more like consent from the customer also needs to be obtained. Then you need to perform a systematic risk assessment. So basically, what are the technical best practices that needs to put in place? Data governance. You cannot overemphasize your data governance. It's very, very important. So you need to make sure that a top-notch quality assurance process is in place around your data. For sensitive data, what are the things you put? Do you encrypt the data, for example? Okay. Do you anonymize the data? Okay. Data in motion, data at rest, the encryption method that you put in place. Okay. Who should have access to the data, and so it's only people that are needed, that access is needed, that should be granted. So you need to also implement something called least privilege. Only people that need the data access should be granted. Data loss prevention, DLP, needs to be implemented or needs to be in place. So those are the things, those are the best practices. So provenance tracking, what that means is that how do you track data within your AI system from start to finish? So within you've automated your processes, for example, how data is being used from end to end. So that needs to be tracked, and that needs to be in a log somewhere, and it needs to be documented. It's even part of the EU AI Act. So all your data, for example, you need to put logging mechanism in place. Your lifecycle management for the entire, AI system from end to end. How do you ensure that all the information are put in place and all the information are working as expected? Then transparency, you need to make sure you are transparent. We don't want to deal with something called black box, right? So because one of the key risks around the AI system is black box. People don't understand the model you're using, the algorithm that is being used. So it's something that you need to provide the code whenever it's being asked, so that people can review and do a audit around it. Okay, so privacy and data protection. So what this means, that there has to be privacy by design. I mentioned that. So you need to embed data minimization and protection early in the development, which is very, very important. Collect only only data that is necessary is what you should collect, and just for specific purposes. Then you also need to obtain consent from your user. Make sure that user gives explicit user permission. So, and also federated learning for data anonymization to reduce risk. So protecting your data, the data that is being used for the AI system, is very, very important, because these are users' data, right? So privacy by design principles, embedded data minimization, and protection early in the AI development process. So all AI systems must align with GDPR and regional data protection, the likes of California consumer protection rights, shaping. Okay, so this is specifically for EU, and making sure techniques are put in place to reduce privacy risk, while also at the same time maintaining AI functionality. So this is very important. So what I've discovered is that now that we have these policies or regulations in place, a couple of people have gone back to go and update their data policies, right? Because there's a thin line in between your data management and also your AI. So you need to, all those policies, a couple of policies, even some cyber security policies also needs to be updated to be able to reflect this. All right. Thank you. My system hung for a while. So security and resilience. So we have testing needs to be in place to model your vulnerability. You need to ensure that security, supply chain security practices help to vet AI hardware and software dependencies. So making sure you put enough security in place, within your AI system. Very, very important. Okay, so not only are you supposed to achieve that, you also need to make sure that security breaches you are eliminating security breaches, right? So what we have here is a landscape of your global AI policy. So we've seen something from the EU, also from the North America, Asia. So this is just like the landscape within the AI policies. So accountability and oversight. So let's talk about accountability and oversight, right? So you need to clearly define the roles. Now that we have a couple of regulations in place, right? What do the organizations, what are they expected to do? So number one, you need to establish defined roles. So for example, we've seen a couple of high-valued organization or banks in this case, they've appointed something called Chief Risk Officer. Oh, sorry, Chief AI Officer. So CAIO. They've appointed Chief AI Officers that will oversee the entire AI system within the organization, and also teams in place, like the people expected to all those stakeholders I mentioned earlier, the legal team, the GLC team, the developers, the AI developers, the people that are supposed to test the AI systems before it goes into production. So all those teams needs to be clearly defined within AI policies, and it's good to have a AI policy that addresses the regulations that the organization reside in. Then having audit trail, I think I talked about audit trail, very, very important. So audit trail, so all what your AI system is doing needs a log needs to be generated and saved somewhere in case anything goes wrong, because there will be a couple of incidents that will occur within your AI system. So you need to make sure that you have logs, all logs are enabled to ensure traceability and third-party validations, of the AI systems through comprehensive documentation and external assessment. They need to have another body that does a review, an independent review of your entire AI system. Remember, I talked about earlier about transparency. So how can we achieve transparency? It means probably a third party or someone else, an independent person, had come in to come and review the model or review the algorithm, review the output of the AI to make sure that it was designed as intended. Then establishing ethics and governance body, very important. You need to have like the same way in where we have steering committees. So we have to have a body that oversees, like a governance body that oversees the entire AI system. So it could be someone within the board, some set of people within the board specifically should oversee the entire AI system. So establishing committees for ongoing oversight to provide guidance, for ethical considerations and governance. So the CIO can be on that board, the chief AI officer can be on that board, the chief legal officer can be on that board. So, but there has to be a board, a committee responsible, for an oversight of the entire AI. Okay. So let's talk about transparency and explainability. So having comprehensive documentation in place is very, very important. Making sure that we have explainable tools, okay, also very, very important, and user-centric explanations, also very important. Then we have data privacy and protection. Your data minimization needs to be in place. Your purpose limitation also needs to be placed. You need to make sure that you get users' content, very important. Then GDPR compliance, or complying with the required data privacy regulation for that area or for that country or for that continent needs to be in place. Then also regional regulations. So security and resilience. So making sure that we put enough security in place. A couple of testing needs to be done. So this is how this is linked to cybersecurity. So we all understand that even though we are using AI, even the cyber criminals too are using AI, right? So I need to make sure they'll test for vulnerabilities before I mentioned earlier that security by design. So put enough security in place. So at the stage of testing, do a couple of testing, stress load testing, security testing, vulnerability testing, testing that the code is secure, testing that there are no inputs input. There are a couple of inputs validation, okay, and there's no SQL injection. Doing all the checks based on the OWASP. I'm not sure we have the OWASP top 10 vulnerability. So we have a couple of vulnerabilities that have been defined by OWASP. So all those, tests needs to be done to make sure that you have a robust and a well-secured AI system. So we have your red team exercise. So red team are like the hackers that try to simulate any hack, okay, within your AI system. So they come in like the bad guys to come and do a lot of hacking attempts within the entire AI system. So the AI system needs to be subjected to that before it goes into production. Then also you're vetting your AI dependencies, because there are a couple of probably your AI system is integrating with another AI system. So you need to check there's an API integration with another thing or another application. All those needs to also be checked. Then third-party risk mitigation, managing external vulnerabilities. So majority of the organization, they outsource this particular AI system or solution to another third party. So you need to make sure that there's a risk around that and controls in place to mitigate that risk. Monitoring, auditing, and compliance, ensure continuous monitoring. You need to set your KPIs in place. Risk indicators and threshold. So you need to also, for your risk, how do you ensure that this risk doesn't crystallize? So the way you can know is to make sure that you're checking for your risk indicators, and there's a threshold. If your particular if the KPI reach a particular threshold, something has gone wrong, for example. So maybe, for example, you have your sensitive data in your data, okay? Probably the level at which you have the sensitive data within your pool of data is not, let's say, encrypted, for example, or is not anonymized. But what that means is that there will be a threshold. So if the threshold is, let's say, to me, I would say all sensitive data should be encrypted, or you should anonymize it, right? So if your threshold is saying 1, for example, okay, which typically should be 0 to me, okay? So if it's more than 0, then there's an issue, right? So that way you can actually monitor it using your KRI. So that is a risk, key risk indicators. Automated alerting system, in case anything goes wrong, who should be alerted, right? And I think based on the regulation, in case anything goes wrong, okay, I think in the EU AI Act, you should notify the relevant authority within 72 hours, if I'm not mistaken. So you need to alert, so your system, probably your compliance team, or the way the rules are being defined, a couple of teams needs to be, alerted in case anything goes wrong. So they will see how they can easily mitigate, address it using, there has to be also, you need to implement. So remember I mentioned that now that AI has come on board, you need to probably go and update your policies, update a couple of things. So one major thing that needs to be updated is your incident playbook, okay? We all know in cybersecurity, if there's an incident, for example, maybe there's a cyber attack, there has to be a playbook that say, oh, there's a cyber attack. Number 1, what do you do? Number 2, what do you do? Oh, probably you quarantine the system, for example, and you quarantine the system, take it offline, and you investigate the issue for you to come back, for you to be able to restore your operation. Probably there's a backup somewhere that you probably need to restore and start putting processes in place. So that's like what your playbook, is specified. So what that means is that you need to also have a playbook for any AI, for any risk that has to do with AI. So which means you have a new playbook if you don't have it already, that needs to be in place. So that's, once the alerting system is done, then you now initiate whatever it is that has been defined in the playbook. Then also the performance tracking dashboard, how you track your performance, how your AI is working effectively to be able to track performance. Then external certification, you have your ISO 42001 for AI management. So the organization can decide to certify on that. They also have the industry specific standards, your AI, your third-party verification, your compliance attestation. So in case the organization wants to certify that their AI is compliant based on a particular regulation. Transparent reporting, there will be couple of regulatory disclosure requirements, especially in the EU AI Act, because once it takes effective in 2026, August 2026, there will be a couple of, regulatory requirements and disclosures. Stakeholder communication is also very important. I've talked about incident reporting protocol. Who are the people, in case there's an incident, who are the people that needs to be notified, and what are the things that needs to be done? So public transparency and statements. So in case probably there's an issue with an AI that has to do with privacy, okay, so we need to make sure that you need to be ethical enough, okay, to be able to inform the public, oh, this was what happened and this was how we're able to resolve the issue, and probably there was no risk or there was no issue around it. So also those needs to be in place. Then so emerging threats, we have generative AI investments. So about 33.9 billion in 2024 funding was done for generative AI, sustainability application, climate modeling, resource optimization, so that the things are actually coming. We also have things like agentic AI also. So we have the EU AI Act, okay. So I think I mentioned earlier that EU continues to bring a couple of revisions. I also mentioned that there are a couple of clarification that needs to be done based on the AI. So there's also come and to do a couple of revisions. So harmonizing with international standards, adapting to technological developments, refining risk categories, okay? So before earlier, so now I think there's more specific on how those categories are being refined and more examples on the AI application that has to do with the risk level. So AI for sustainability, raising focus on climate, environmental and social impacts, also climate change mitigation application, resource optimization solutions, environmental monitoring system. So these are the emerging trends or the future direction that we are seeing for the AI, for AI. Then also education and workforce. So within the education and workforce, we are adopting AI competency frameworks for students and teachers, because there are a couple of questions that are now coming on board. Now that for schools or in education, that you give your students, previously, probably if you give them a paperwork, they'll probably go and do a thorough research, and start referencing. They will take a couple of books that have been written by scholars and start referencing, doing their own research. Now, you can give that particular topic, you can just throw it into ChatGPT and say, let me write a paper on assessment of the nanotechnology within the entire landscape. ChatGPT will give you a very good, write-up with references. So how do you now manage that? So there are a couple of policies that are now coming on board, even in the educational space, on how those needs to be AI needs to be embedded, within the educational workforce. So moving on. So what are the recommendations and next steps? So I think I talked about almost like 6 frameworks. Okay, so how do you integrate the frameworks? So depending on the organization or where that's the organization where you see yourself, okay, you just to pick the regulations that applies to you and how you can mirror it, or how you can make the regulation to have your own policy in place, okay? Also engaging stakeholders, very, very important. Prioritizing your investments, also very important. And maintaining regulatory watch, also very important. In case anything goes wrong, what are the things that needs to be done? Multi-framework integration, combine these entire frameworks or regulations that has to do with, or that has to apply within your landscape for a robust governance. That I talked earlier, for example, you have the EU AI Act, then we have the AI risk management framework, the one for the ISO. So you can use the AI management framework to how to describe or how to mitigate risk, your AI risk. Now, using the EU AI Act, all the things that have been, all the requirements that have been embedded there, you can, so it's just for you to pick which regulation that applies to you to be able to suit your need as an organization. So map complementary elements across the frameworks, identify organizational priorities and gaps, develop integrated implementation roadmap. So remember, for EU AI, for example, all organization within the EU or organization that EU citizen uses the AI system, they need to be compliant, in compliance by 2026. So what that means is that the organization also needs to put processes in place on how they need to, address that before 2026. Develop integrated implementation framework. So that's be a framework, for example, identifying roles, putting policies in place, enacting the policies, ensuring that all the risks are being identified and mitigated. Then also stakeholder engagement, foster policy development across the sectors, establishing multidisciplinary working groups. So you need to have a group that work, to ensure that you have good AI governance in place. Very, very important. Investment priorities, so allocating your resources to transparency, risk management, and capacity building. Then regulatory watch, okay, ensuring that you have established your policy monitoring, so continuously checking for if there are any new updates from any regulation or any regulation within the sector at which you operate. Then at that time, updating your policies. So most of the time, well, 100%, almost 100% of the time, all the policies should be due. There has to be like an annual review of your policies anyway. So, but in case there are any updates, then it calls for a review or an update of the policies to be able to align with the required regulation. So, thank you very much for listening to me. I think we have 5 more minutes, if I'm not mistaken. So, I'm available to ask any question. Thank you for your time.
Hello, congratulations, Dr. Olama, for your beautiful presentation.
Thank you.
We enjoyed it very much.
Thank you.
Hello?
Yo,
Dr.
I'm with
Olama,
you. Do you have any question? Thank you very much, Professor Dana York.
beautiful presentation. Congratulations.
Thank you so much.
Congratulations, and please come to New York the 12th of October. We're gonna
Okay.
have a boost of happiness,
Okay.
and it's a beautiful lecture.
Oh, right.
So what
All
do you think for the future? What are your plans for the future?
So right now I'm still in I'm connecting from Dubai, UAE. You never can tell. I can be in New York in the next 3, 4, 5 months. So thanks for the invitation. So Fabi can maybe Kiran can send me an email concerning that with the details, and I'll love to give my feedback.
Wonderful. Congratulations for your beautiful lecture.
Thank you so
See
much.
you.
Thank you. Thank you.
Kiran, please present the next speaker.
Our next speaker is Mrs. Cynthia Akiotu. Mrs. Cynthia is a cybersecurity leader and a data scientist who passionately advocates for digital transformation. With a master's degree in financial technology and bachelor's degree in computer science, she holds multiple professional certificates demonstrating her commitment to continuous learning and industry excellence. Cynthia has several years of impactful experience spearheading innovative cybersecurity and data governance projects. She notably co-authored the influential chapter utilizing AI and machine learning for regulatory compliance in financial institutions, reinforcing her reputation as an authority, bridging technology, regulation, and ethical best practices. Cynthia consistently drives insightful conversations around digital transformation, ethical AI deployment, cybersecurity, governance, and global data protection standards, inspiring change across diverse professional communities. Please join me in welcoming our keynote speaker, Mrs. Cynthia Akiotu. Mrs. Cynthia, are you there?
Yes, I am.
Could you please speak a little bit louder?
Okay. Can you hear me now?
Yeah, it's okay. Perfect now.
Okay, thank you. So thank you for the introduction. I would like to start with saying that we gave AI a seat in cybersecurity without defining the rules. So I'm glad to be here to be presenting the use of AI and cybersecurity. where do we draw the line? So as Kiran has introduced me, I'm Cynthia Kyoto, a cybersecurity specialist as well as a data scientist. So I'll also ask a question. With the age of AI, how many of us haven't used AI? I don't think there's anybody in any way that has not used AI. It could be through generative AI, maybe ChatGPT, Microsoft Copilot. Even in our homes now, we have Internet of Things. For example, you can even speak to your television, you can speak to your phone. Let's take, for example, when we call Alexa, what's the time? So we are all interacting with AI directly or indirectly. Even those who are not technologically inclined sometimes have contact with AI. So I'm going to start by saying that I'm not going to bore you with too many technical jargons. So just stay with me on this presentation. I'll also say, I read a report recently where it states that by 2030, AI investment in cybersecurity is going to increase by about $135 billion. That shows the importance of AI in our daily lives. AI is being used now in the health sector, in the financial sector, even right at our home and education spaces now, AI is used. That shows the importance of artificial intelligence in our sector and our environments today. Starting, I can now ask a question. Can AI really be our cybersecurity superpower? How are we using AI in cybersecurity? I know it's like a dual-edged or a complex issue where AI is being used as a shield and at the same time as a sword in cybersecurity. But I would also like to talk about the relevance of AI in cybersecurity. AI is used now in prevention, detection, response, and even in analysis. We already know the benefits. I'm sure lots of us know it has resulted in cost savings for some companies and organizations, scalability, where you can easily automate cybersecurity process faster, unlike when it was just the traditional way of working with cybersecurity analysts, and lots more. In prevention, it's being used in smart authentication and password protection. Now we have the CAPTCHA. For example, now when you want to impute your password, you kind of see something like a CAPTCHA saying, do this, type this number or type this alphabet to confirm that you are not a robot. Let's even forget about that, because now technologies in the technology space, we are advocating for a passwordless system. Now we use even biometrics, like your fingerprinting, your face. I'll give an example. We have, for example, I love Microsoft technology. So when I give my examples, most times I'm going to be using more of Microsoft. We have the FIDO2 security. We have the Microsoft Authenticator app. I'm sure some of us or most of us are conversant with the Microsoft Authenticator app. So that is how AI is being used. It's used also in vulnerability management, where you use it to identify loopholes or exploitation within your system. Identify even zero-day malwares that could not be addressed using traditional cybersecurity detection systems. It's being used for phishing and email threat detection. I'll give you an example. We have email spoofing in the Microsoft 365 technology. We have the zero-hour auto-purge system. What does this do? For example, when a phishing message is sent to your email, the zero-hour auto-purge indicates or detects that email that it contains anything malicious and quickly retrieves that content before it spreads to the system or before the receiver of the email clicks on that link. That is to show you how fast and how AI is revolutionizing cybersecurity. AI is turning novices into experts. Everybody is an expert. Let's talk about it. Even now, AI is even like a doctor. For example, some people, once you have something, you're experiencing something, you type it on AI and AI is already advising you. We have conversations with AI now in our daily life, sometimes it's like our friend. So it's also making cybersecurity easier. Before, maybe you may need to learn lots of languages, maybe the coastal query language, KQL, Java, and all. But now with AI incorporated into cybersecurity, you may not likely have to know the details or the integrities of these languages, but you can still practice as a cybersecurity specialist. It is used in threat hunting. We have the Microsoft Defender for endpoints. These are tools I use in threat hunting. We have the Microsoft Purview being used for data loss prevention. All these are incorporating AI. Even now with AI, before you sign in into your system, maybe it can verify you based on your identity, your location, using different signals. That is how you can see the relevance of AI in cybersecurity. It also checks when you want to log in, is this device from the actual location or not? It's used in behavioral analytics. So see where the location of this person, is this the location where this person normally sign in normally? If not, it notices an abnormal fluctuation and flags that sign-in. Lots more, if I continue talking about the superpower, like I call it, of AI in cybersecurity, I think the list is endless. So I will take you to the next slide. The dark side, AI as a cyber threat. We've gone around the news, you see lots of information now on AI, the beauty of AI. And you also see the bad side of AI being in when it is used as a cyber threat. Before I start giving you scenarios, let me make it simpler so you might not look at this, my slide, as a technical jargon. I want to help you understand the meaning of deep fake, what it means to have deep fakes, for example. Deep fakes basically is eroding our digital trust. What is deep fake? Deep fake is when either your audio or maybe audio or videos are being manipulated using AI to convince someone. The audio or video can look like a friend or even a CEO of your company just to convince you to do something. That is what it looks like. Large language model poisoning. What does it mean? For example, now we know that data is being used to train all these models. Let's take, for example, ChatGPT. Imagine if malicious data on misinformation is being misinformed data are being used to train these models like ChatGPT. Let's take it to the layman's side. I am a teacher, I teach, and then I give students fake textbook telling them 2 + 2 is equals to 5. That student is so confident and he goes everywhere saying 2 + 2 is equals to 5 because he learned that. That is what large language model poisoning is about. Then let's talk about AI-assisted malware generation. I would like to break it down. Some people will call it, I'll call it polymorphic malware. What is a polymorphic malware? A polymorphic malware is where the malware is in the system and it keeps changing its structure so that it is not detected by traditional security detection systems that normally detect malware. I want to put it in another real-life analogy. Imagine there's a criminal. The criminal goes about carrying out criminal activities. He disguises his face. Today he's looking like a female. Tomorrow he's looking like a male. Next tomorrow he's probably looking like an animal. Let me use that. It becomes difficult to detect that criminal and say, oh, this is the person, this is the particular person. That is what AI-assisted malware generation is all about. We also have automated exploitation and attack scaling. This is where your system is being exploited. For example, we notice there's a loophole. A hacker notices that there's a loophole in your software and goes in without being noticed and carry out massive exploitation on your system. This time, since it's automated, it is fast even before you detect it. Let's bring it down to a real-life scenario. For example, we have a bricklayer. The bricklayer works in the neighborhood. He is known from going door to door to door to check houses if there are issues. Imagine now the bricklayer now has a drone. The bricklayer sends the drones to different houses to spy on those houses and check if there's a broken window or if doors are opened. And when he notices those loopholes, the bricklayer goes in and maybe steal. That is what automated exploitation and attack scaling is all about. Let's bring it down to scenarios. I'll drag it down. I don't know if you or anybody ever knew or heard about an Arab company. In 2024, there was a deepfake attack where an employee was tricked and he had to send about $25 million to an account, only to find out that it was deepfake, thinking that it was his own fellow employee. That is what it is. I'll bring it now to UK as well. Currently, we have complaints of people using HMRC, prompting you that you've evaded tax, and whereas that's a lie. When you see that, you start divulging your personal information, PII, and then they gain access to your system or gain access to your data and even put you in panic mode. So these are the several scenarios of the dark side of AI. There's also a report that states that about 82% of phishing attacks now is due to artificial intelligence. About 82% of phishing attacks, it was orchestrated by AI. And within September 2024 and February 2025, it increased to about 17.3%. That shows you that AI has made phishing simpler. Even those days, it used to be very simple to dictate phishing emails. When I say what is a phishing email, for example, when you are sent an email that looked like something that came from your organization, and you notice and you see some, and it tells you to divulge some information. That is what phishing is all about. Now, with generative AI, I can just go in, please generate a phishing email for me. And it looks when you read it, it looks very convincing. Before, when I was doing cybersecurity, you hear, when you see a phishing email, you check for typos and all. But now you don't even see typos. So it becomes so convincing. I have now, can AI ever be truly trusted with cybersecurity? That is a question. There's a pendulum between now discussion around the security and the ethics aspect of it. We have adversarial AI, where AI is being used in the negative aspects. I've given you lots of examples. AI being used in phishing, AI used in phishing, AI used for deep fakes, like faking somebody's appearance to convincing you, and you believe. AI, so there are different, that is in adversarial AI. Let's talk about the bias of it. We are still dealing with bias. We've heard of different models being like biased. Maybe when you want to give loans to some particular people, some people are not giving those loans, maybe because of their race, and this is due to the way these models were trained. So that is another one. There's also the issue of compliance and regulation. Yes, we hear lots of compliance regulation policies, the EU AI Act. We have AI governance policy. I was also reading somewhere, I think yesterday, I saw that US has also said that deep search would be used within their system for government work and all. So different regional AI policies segmented here and there, compliance issues, the issue of who is responsible for the AI. Is it the user? Is it the software developer? Is it the government? So whose responsibility is it? So that is where we are now in AI use being trusted in cybersecurity. I also talk about the issue of skill shortage. There has been lots of buzz and noise that there's skills shortage in AI. And at the same time, we also hear of layoff from company where some companies are now relying on AI to do jobs. So they are relying on bots. So the question now is, are we removing humans from the loop? Are we removing human intervention and relying totally on these bots? It's a good thing with UAE. I think the United Arab Emirates, being the most recent, has introduced early learning of AI, the use of AI in early learning, in early education for children to be aware about AI. China, Singapore, Finland are all doing the same. Even within our universities as well, some universities have accepted AI, and now instead you see a note, please use AI responsibly. They know that everybody is using AI to make things faster and seamless. But the real question now is, we've advocated for AI. AI is being used in classrooms. Yes, teaching children AI, they are even assessed using artificial intelligence. Are we also teaching kids how to protect themselves in this AI-powered world? Are we teaching them the vulnerabilities, the risks behind it? So these are questions we need to ask as well. This takes me to this question: how can we protect ourselves? AI is helping us in various ways. And now the question is, how can we protect ourselves from this? Sorry, please. Please, can you keep quiet? Thank you. So we are on how can we protect ourselves using AI? With the skills shortage, we've learned about skills shortage and all. We all should be advocates on the ethical use of AI. If you have knowledge of AI, let people know, be advocates. I was saying earlier in this presentation, I said there are some people who would say they've never been affected by AI, or I don't have an internet-enabled phone, I don't have this, so there's no way it can come to me. I want to give an example. I read a report that the most people affected now with deep fakes are elderly people. I can put a call, an automated call to you, sounding like, oh, I'm your daughter, I'm in a panic mode, I need this money, please, can you send it to me? And you send it right away to the account. I'm calling you, your phone, as far as your phone has a SIM card, I can reach you. So this is where we need to advocate for education of our elderly people, education of children. Then the next thing is for government policies. Yes, we have lots of government policies, but we need to have a unified governing policy that would govern the use of AI as well as its use in cybersecurity. I also want to talk about within our organizations, what kind of systems are we putting in place? As an organization, if you say you are staying laid back, you don't want to implement AI, artificial intelligence is going to catch up with you. So the next thing is to train your workforce about the use of artificial intelligence as well as the implications of artificial intelligence. Also have the appropriate tools and technologies to combat any form of vulnerability and to help in proactively checking for any form of cybersecurity miscramp, hackers, invest on threat intelligence as well. So where do we draw the line? That is my question. I'm asking you, just have a little thought. Where do we draw the line? Here I'm saying there should be investment in AI, investment in AI and cybersecurity related researches. This will help us in a way to be able to have a deep understanding on the implication of AI and what it has in cybersecurity. Another thing is collaboration. We hear of, oh, Microsoft technology has implemented responsible AI practices. Google has implemented their own responsible AI practices. But we need collaborations between public and private. We need private and public partnership. In that way, we will have a form of unified AI governing policy. We need different countries coming together. Sometimes I see it as a competition. What we are facing now is, you see this country implements AI in the curriculum. The next week, the other country brings out its own policy. I'm implementing AI in my own curriculum. I don't see it, sometimes I see it like, oh, let's not be left behind. Let's just follow suit and be among one of the top people doing this. But are we also having a thought of how to make it as a unified system? The next thing I will also talk about is enforcing these government policies. We should have proper government policies in place. Then the next one I call is ethical framework. We need an ethical AI framework. Why I call it an ethical AI framework, that will help us to test the use of AI in a controlled environment. We can have ethical AI red team members who will investigate the use of this AI in a controlled environment before it's being deployed to the outside world. So I will also say this as a call of where do we draw the line? This is what we should not accept. Autonomous AIs making decisions for us without proper accountability. Black box systems. We have black box systems. We just believe, oh, it's AI. How do you know? How do we trust these systems? What information are they riding on? Like I gave you an example of the large language model poisoning. We have lots of weaponized AI left unchallenged due to no policy. I won't say due to no policy. I will say because of lack of unified policy. What we must demand, we need human oversight. Companies now laying off people are now saying, oh, I have a cybersecurity tool or an AI cybersecurity tool that can do this. Let's cut down staff. I feel that's not the right way. We still need humans in the loop for check. To see these oversights and loophole, we need AI transparency, transparent use of AI, and a shared global standard. The next I would like to say is that the danger isn't that AI has crossed the line, is that we never defined one. So with this, I would like to say, with what I have said, what questions do you have? What are your thoughts? What are your suggestions? So I put this to you. Thank you.
Thank you, Cynthia, for most enlightening presentation. Any questions, please? We can always see that we can always pull the plug, and that's very, very important to know that we can always take action and protect ourselves.
Yeah. Can we go with next presentation, Professor Dana?
Yes, please introduce the next presentation.
Our next speaker is Dr. Ricardo Galante. Dr. Ricardo is a passionate educator and lifelong learner. Professor Ricardo has dedicated his career to inspiring future leaders in data science, analytics, and artificial intelligence. As an invited professor at the University of Lisbon, IFAM, Universidade Europeia, and European University, he transforms classrooms into spaces of discovery, blending academic rigor with real-world application. His mission is to awaken critical thinking and empower students to use data as a tool for innovation and positive change. With over 20 years of experience, Ricardo also serves as a principal analytics and artificial intelligence advisor at SAS Portugal, where he drives organizations to harness the full power of analytics. His expertise spans machine learning, segmentation, behavioral modeling, and credit scoring, delivering breakthrough solutions through cutting-edge research and innovation. Throughout his journey, spanning leadership roles at SAS Brazil, Allianz Brazil, Cognitis, Acnilson, and the Secretaria de Estado de Educação do Rio de Janeiro, Ricardo has combined technical mastery with a deep commitment to human development. A dynamic storyteller, sought after speaker, and active mentor, he believes that true success is not only about solving complex problems, but about inspiring people to see new possibilities, whether in the classroom, on stage, or working alongside businesses. Ricardo is driven by the conviction that knowledge shared is power multiplied. Please join me in welcoming our plenary speaker, Dr. Ricardo Galante.
Okay, thank you very much for this kind introduction, Kiran. Let me share my screen with you, guys. 1 second.
Perfect.
Okay. Can you see my
It's
screen?
perfect.
Okay,
Yes.
perfect. Hello, guys. It's a real pleasure to be here with you. Okay, today we'll exchange some information about trustworthy AI. Okay, some points of view that I am working here in Iberia, mainly in Portugal. Okay, so Kiran made a very kind of introduction about myself. My name is Ricardo Galante, and I work at SAS company. I am a statistician. I did a master's degree in Bayesian, inference Bayesian, and I'm finalizing my PhD in Lisbon at Lisbon University, related with machine learning, but mostly related with forecasting. It's a cool thing. If you want, we can change some information about this. And I work a lot with artificial intelligence. In fact, I am a teacher in some universities here, Lisbon University, European University, and so on. And I teach data science using a lot of I think different approaches, okay, to teach our students in this way. So let's start our conversation, our journey, okay? Artificial intelligence. When I start to talk about artificial intelligence, we need to talk about this kind of thing. We need to talk about the evolution. And it's not new. We start this kind of conversation in the 50s, okay, with Alan Turing, with Frank Rosenbaum, when they start talking about the perceptrons, the Alan Turing, and so on. So this is not new, but from there we have a lot of evolutions. In fact, we have evolutions day by day, daily. We have different things appearing each day related with artificial intelligence. Here I put the main. It's not all, of course, because we have a lot of things, but I put the main topics: machine learning, deep learning, generative AI, NLP. So, and this is more or less our timeline related with artificial intelligence over the time, okay? And we have some good points. When I did some researchers about this, and we had a lot of financial investment related with artificial intelligence starting 2021. It's not from there, but I choose this timeline until 2024, and is expected to have much more financial investment, okay, until 2030, okay? A lot of investment in this area. We are all working with this kind of thing. But in the opposite, we have problems, okay? It's not so perfect. And here I put some problems, documented problems that started appearing in 1988. I think we had much more problems, but I think I put here some documented problems, okay? In this case, were related with bias in a hospital. And I put different problems along the year, okay, over the time. And here we have much more. Each ball here represent a problem related with bias, relate with a lack of privacy and things like that. So it's a problem. In fact, we have this kind of situation. We have the two sides from the same coin. we have the risk of using AI, as we saw right now, and we have the reward, okay? So it's not possible to avoid risk. We need to live, to convive with this kind of thing. And we need to have the reward related with the use of artificial intelligence. And how can we do this? We can do this with trustworthy AI. This is the idea. Trustworthy AI is a way to combine or to put in the same equation the risk and the reward, okay? And I put here this exactly this thing, okay? The balance between the risk and the reward related with artificial intelligence. So trustworthy AI is the idea is to develop and use artificial intelligence in an ethical way, in an ethical manner, okay? We can talk about ensure that AI does not harm people or harm society. This is the most important thing related with ethical AI. This is a cool thing. We need to change the way that we are asking. Not could we, but should we? This is the idea of trustworthy AI. And when we talk about the business related with artificial intelligence in an academical way or an industrial way, we need to reflect which value this brings to us, not to only to myself as a person, but to our society, our countries, our kids, our generation, and so on. This is the idea of trustworthy AI, okay? But why should we care about this? What is the problem? Why is this so important, okay? We could think in a different angles. We could think in we want the well-being from the humankind, for the society. But in fact, here we have at Europe the regulation called AI Act, okay? I talk here a little bit about this kind of regulation, what does mean, and what is the impact in our lives, okay, in terms of academic and industrial way that we will work from now on, okay? So the point is, this is the definition of AI Act, okay, is a European Union regulation that governs development. The focus is use artificial intelligence within the Union European, okay? The goal is to ensure that AI systems are safe, respect fundamental rights, and foster a competitive UI AI market. This is the definition of this regulation, okay? And here I put I think some interesting point, because it's not new. This is starting 2018, okay, when the Commission from Union European, they agreed to create a document like, okay, let's work. We need to work with this, but let's create some rules. Let's create some guidelines, okay, about this kind of thing. And here I put the entire timeline about the AI Act. The beginning, okay, in 2018, and you have different guidelines or points over the time until March the last year, when the law was approved, okay? I put here the information about Portugal. I am in Portugal, but I put here the Portuguese law and the Spanish law. We have different laws, each one by country. We have the French, Belgian, United. We have, for instance, in some countries that they create by law, trying to be agreed with the main one related with AI Act. Not only by countries, but we have the same law divided by industries. For instance, here I put EIOPA. EIOPA is the regulation related with AI Act, but for insurance companies. So it's not only related with countries, it's related with industries itself, okay? This is the idea. Everyone is concerned about this kind of thing. How can we use AI, but in an ethical way, in an ethical manner, okay? This is the point. So what are the challenges? Here I put some challenges that we are facing, okay? The point related with transparency and privacy, the explainability of models. We have very good models, but how can I explain my models that I am using? Points related with bias and discrimination, okay? This is a very important point. And how can we work with this in an ethical way, in a way that I will avoid harm to people, okay, or harm organizations. And when you take the AI Act, was created some levels of risks. Okay, we have from level 1 until level 4. We have the level 4 is the minimal risk when we are using artificial intelligence. Is totally allowed because video games, anti-spam filters, and so on. When you are in the level 3, we have low risk. We have risk, but in a low way. Is related with chat bots, call bots, voice bots. When you enter in the level 2, in the second level, we have high risk. Okay, and this could affect it. Okay, this could be a problem related with classification, and in this way we can have bias. We could have some constraints in terms of people or gender, ethnicity, and things like that. And we have the unacceptable risk. Okay, it's the prohibited AI practice. All these things were created in the AI Act. Okay, of course we work with the high risk because it's, I think, the most important thing. The minimal and the low, it's not a problem. And the unacceptable, we are not accepting this kind of thing. So this idea is put our focus in the right risk level. Okay, so one thing that this is the pillars that we have in the AI Act. In the human centricity, we could have very good models, very automatic models, but we need to have the human in the center of the process, taking decisions. We need to be transparent in our data, in our algorithms. We need to be inclusive. It's not possible to exclude some group, okay, based on ethnicity, based on the religion of these people, or gender, and so on. Need to be robusters, okay, in terms of assurance, in terms of process. I need to be need to be accountable. I need to identify the responsibles of things, and in the end of the process, we need to respect the privacy of the data. So this is more or less the pillars that we have in the AI Act, and they are inclusive in this process. When we think in a software, or when you think in a process that work with intelligence, with artificial intelligence, we need to take in consideration this kind of thing. Okay, so I work at SAS. SAS is a company, I don't know if you know, but I work at this kind of company. SAS is an American company. The SAS means, this acronym means Statistical Analysis System. This company is in the market, I don't know, a long time ago. We entered the market a long time ago. And we work with statistics, with artificial intelligence, advanced things. But how can SAS could help in this context? Okay, in this context related with artificial intelligence. So this is the structure that represents a SAS as a software. SAS is not only an algorithm or a dashboard or a model. SAS is a platform, a complete platform. We have some modules. We have the first module is related with data, the data ops, the data governance. The second module is related with analytics. Since from the basic statistics like a Q-square model or correlation, until the deep learnings, the LLMs, and so on. So is the moment where we create, or the place where we created analytics. And the last part, the third part, is related with deployment of the process. What does mean deployment? Is related with the process when we put in production. For instance, suppose that you create a model and you need to put this in a cell phone to be run it, to do like a recommendation or a credit score analysis, things like that. So the model was in our mind, the model was created not only to be in our computer, but should be placed in secure turbines and computers and websites and cell phones, video cameras, and so on. So this is the idea. SAS is not related with one of these parts, but all of these parts. So for this reason, I put this image representing the platform. And here I put the modules, the interface, okay, of each one of these parts, the data preparation, the information catalog, where we have all the information about the data. Think this in a bank or in a hospital or in a energy company. And here we could have the information about all the data that we have, the data discovery, the automated analysis. The data mining is very cool because here you can work, of course, with SAS, with advanced analytics, but you can integrate with any kind of open source. You can work with Python, R, Databricks, and so on. For this reason, I put the open source here. Okay, this is our interface related with Jupyter Lab. Model management is a possibility to have all these models in the same place. Okay, like a repository. Suppose that I create models in SAS, but I create models in R, Databricks, H2O, Python, and so on. And I could have all these models in the same place. Okay, to not only to have a repository, but also to manage these models. To, for instance, to check when these models is not so performatic, when it is necessary to retrain the models. And the last part is the intelligence decisioning part, is the possibility to integrate these models, these structures with decisions. Okay, so this is called intelligence decisioning. So more or less in a general way, we have here the main parts related with SAS. And my intention is do a demonstration, a quick demonstration for you guys. A good thing that I would like to share with you is that we have the same platform in academic way. That means that we have this for free, okay, for free. We could use this, of course, in academic way, but even I have my academic mail, I can use this inside universities to do research, to teach my class. For instance, I teach my classes using SAS. Okay, my students and my colleagues learn from my classes using SAS, integrating with open source and so on. So if you have any doubts, please contact me and we can talk about this. How can we use this? How can we use SAS in academic way? But this is the idea. I will do a demonstration here, and my intention is like I will think that I am simulating a financial context where we have a default credit card customers. So we have a table, okay? It's a simple table which each line represents a customer with a lot of information. That we have demographic information. We have the relationship from the customer with the banks and a lot of things. And we have the information about these guys related with if they pay or not pay a credit card. Okay, it's a simple one. It's a classification model, but my intention here is present to you a combined way to see every part of the analytical platform. And in my demonstration, I will work with this. This is considered a high-risk model. Why this is considered a high-risk model? Because I am classifying my customers, okay? And this is a high risk because I could put, for instance, gender. I could use, for instance, ethnicity and things like that, and this could harm. This could be a problem in a company. Provide or not, for instance, a credit or a insurance. If a guy have a gender A or B or have the kind of ethnicity or things like that, this is a problem. For this reason, this is considered a high risk model. And the flow that I will use is more or less this one. I work with data. I will model. I do the management of the models, okay, and I will deploy the process that I am working, okay. So let's move on. I'll go to the demonstration. Let's exchange the screen here. 1 second. I'm assuming that you are seeing the blue screen.
Yes, we can see.
Okay, perfect. So this is the cockpit, okay, the entrance cockpit from SAS. I will work with this data set. Let me show you. It's a simple one, the same that I showed to you some seconds ago, okay, related with credit card default, okay. And here we have one sec. Here we have the entrance cockpit. So here we have the different parts: information, assets, develop code, explore, build models, manage models, build decisions. This part represent the image that I show you, okay, related with each part of the SAS platform. So only for you see, I can go here and came here and click on manage data, only for you see that we could, of course, I can import local files as we have here, but I could have, for instance, if I click in add, we have different connectors. So I could use Amazon MRM, I could Redshift, I could, for instance, different clouds, Databricks, Google Data Proc. I can use here, I can select here different ones like Salesforce, SAP HANA, and so on. So it's only for you see that every connectors, or the majority of them are here, okay? I need only to use them if I want, okay? In my case, I will import the data set, this local data set that I show you right now. I will select a data. In fact, I already did this. And I will move on to the information catalog. Here, we have the information about the data set that I show you related with default credit cards, okay? This is a Portuguese data, okay? We have a different information about some customers. And here, we have, is very interesting because in automatic way, SAS provides us with like a summary of the data. This part is not created by myself, was created in automated way when this data set is related with this information, related to, we have this kind of variables and so on. And here, in automatically way, it provides us what the variables I mean, is like a columns that I have in my data set. We could have here the information about what does mean a private variable, what would be a sensitivity variable. I didn't do anything. This is in automatic way. He is pointing me out that this variable could be a private variable related to age. If I have here gender, it will be the same. And here I could see, I could check the variables. Okay, each line here represent a column in my table. And we have the distinct values, the mean, arithmetic means, okay, and an average, in fact, the median, the minimal value, the maximum standard deviation, missings, skewness, kurtosis, the quantiles related with the distribution of each variables. We have here the metadata measures. And I think the most, the point that I really like is related with the quality. So here we have the completeness, the uniqueness. We have the most common value, the less common value, and a lot of information that could help us to identify our data. For instance, if I click here in loan, in this variable, I just click here, and now we have the information about, of course, the information in a statistical way. We have the distribution of the variable. We could see here the graph with the skewness and kurtosis. And here we have the box plot. So a lot of information. This is cool because I could check this data before start a model, okay? Before start a model. So after this, I'm moving in my analysis, okay? I pass through the exploration part. I will do this in a quick way, only for you see the main parts. And here, I did this, only for you see. Okay, and here, okay. Let me put here, I will view report only for you, should be better for you. This is the data, okay? I am in the reporting part. I'm in the exploration part. This is the data that I show you. And here we have an overview of the information, okay? Here we have, this is the map of the Portugal map, okay? But could be Turkey, could be United States, could be anyone. In this case, as I am using a Portuguese information, I have the Portugal, okay, here in my map, and of course these things are totally related. We can see this combination, and here we have the descriptive and its descriptive statistics here, the quality measures, the same that we saw before, and here a very cool thing. Suppose that I will do this. Let me do in a different way. I will do this. I will do it alive with you. Suppose that I want to do a model in automatic way. I can go here. Bet is the variable. That means that represent the guys that pay or not pay the loan, okay, the credit that they made. If I click here and select explain, hey SAS, explain to me on this current page. If I click here, Here I have the model in automatic way, and now we are having the most important variables until the last important, the last important variables in a very easy way, okay? And here we have the explanation of each one of these variables, okay? Only for you see that it's totally automatic, and I can create different models. I call this business model. I have a decision tree, I have a logistic regression, I have a random forest, and I have a gradient boosting here. I did this in a very easy way, and we have the model comparison. Show which was the best one. But this is not a data scientist thing. This is a more business guy, business analyst. Okay. Suppose that I am a data scientist. I could came here in the same SAS, in the same structure, and I go in the build models part. Okay. 1 second. This content is blocked. Let me. 1 second, guys. I don't. This is different for me. I don't know what is happening here, but I will try for the last time. Reviewed modules. 1 second. Let me do this. Is alive, okay? This kind of thing happen when we are working alive. Okay. It's quick. 2 minutes more. I will finish my presentation. I don't know. Oh. 1 second. I do this. I go in a direction, different way. I log in here. I am almost finished my presentation. I would like only to show you the governance part, because I think this is very important.
Yeah, no problem, Professor.
Okay, thank you.
Yeah, please go on.
Okay. Yes, I think now, yeah, we are good. Okay. And so I came from this part exploration, and I go to the build models. In this part, we can create models. I will open the project that I created. Okay. And only for you see, I create some models. We call these pipelines. Okay. I create models. This is the data, this blue box. And I did some imputation, and here I have a Python model. Okay, if I open here, you can see the Python code. It's a simple one, but it's only for you see that I am using a scikit-learn here. Okay, I have an R model here, and I have a gradient boosting here, and I have an advanced pipeline with a lot of this. Each box that we have here are a different algorithm. This algorithm was created by this part here. I will create a pipeline, for the pipeline number 4, for instance. Only for you see the how can I create from scratch, okay? This pipeline. Here you have different algorithms. So anomaly detection, clustering, feature extraction, feature machine, and you have the supervised learning, a lot of algorithms, Bayesian inference, GAN models, post-processing, and keyword, and miscellaneous. We can work with open source and so on. And in this case, I created some models combining different informations. But the most important part is some details that I have here. I will open this gradient boosting here only for you see. And here we have. I am open the gradient boosting. In this case, we have the normal things, we have the ROC, KS, and so on, the assessment related with gradient boosting. But here we have the model interpretability. This is a very important thing that we have. Remember that we are working with a gradient boosting. It's a machine learning model. It's very difficult to interpret. It's very difficult to understand the parameters. And here we can see, for instance, suppose that I work with this variable, the value of the loan, okay? Here we can see the probability, when the probability is increased or not, based on the model that we created. And here we could have the same variable, but divided by clustering. This means that SAS create a segmentation in the data and create different models for each segment. It's a very cool thing. It's a very cool thing. And now I can interpret my model, but using this kind of thing. Because if I look in the parameters, it will be impossible. And the last thing is related to fairness. And these we have the different variables. And in an automatically way, we have the bias being analyzed. And I could, here we have some variables, job, for instance, we have the reason of the loan. And we could see with different metrics like Max, Komogorov, Smirnov, or multi-class log, and check if you have or not bias in our models. And from this, we can work with in a process to mitigate this bias. To finalize my presentation, I will go to the managed models, that part that I show you, that we could have we can governance the process, the entire process. And here we have the models that I created in that interface. Here we have the different models. We have open source models, R, Python, and so on. And this is a very cool thing, because here is like a cockpit where allows us to work in a governed way. And I could here, for instance, I could check the performance of the model. And if I click here in the gradient boosting, we could see, for instance, this is like a snapshot from the model over time. Okay, suppose that model was published in different periods of the time. So I could came here, and for instance, I click in loan, for instance. We could see here in the first, suppose that was first quarter, second quarter, third quarter, and fourth quarter. Here we have the distribution of each variable in this quarter. I could check here and identify, for instance, which variables are stable or unstable. Suppose I think I have some stable variable. Let me see. For instance, this one is very stable because every quarter we have the same distribution. Did you get it? My point. Here we have unstable when I click here, because we have different formats. But when you have the same line represents a very stable variable. And we have a lot of information that we could explore. If you have time, I can explore the very details. And to finalize my presentation, we can publish. So I can came here, and let me put this part here. I can came here, for instance, select a model that I would like to work, and publish these models. And in this case, I can put this in my case here, in my demonstration. I don't have a lot of destinies, but here I could have clouds, for instance, Azure, Google Cloud, AWS, or even GitHub. So I could put in a different destinies and publish this model in a different way, or put this in production in a different way. So guys, this is more or less the thing that I would like to share with you. Let me go back to to see you. Okay, 1 second. Let me 1 second. Yeah, now I can see you. So this is more or less, I think we have a lot of things. I show you only the top of the iceberg. We have a lot of things, but if you have any doubts, is a pleasure to help you or to answer the questions.
Yes, please, Dr. Ricardo. Congratulations for the most beautiful presentation.
Thank you.
I would like to learn. If you want, we can make a meeting so I can give you data and see how it goes to Python and what happened to the data.
Perfect. Let's have this conversation. Will be a pleasure. Will be a pleasure.
Wonderful. Any questions? So what do? You take the data, right?
Yeah.
And then you put it there, and then it goes through all the rest of the. Then it gets processed.
In automatic way.
With Python, yes?
Yeah, you have in Python. You can code using Python inside SAS, or suppose that you use Python in your Spider or Jupyter Lab or Jupyter Notebook. You can connect using some APIs. We call this SAS CTL, and you have the Python code, and in automatic way, this code will be connected with this environment that I show you. Okay, totally automatic. So you can choose. You can work with Python or R or inside SAS or outside SAS, and have these graphics, these visions. So it's easy. It's very cool. It's very cool.
Wow. We are open for questions, please. Thank you so much, Dr. Ricardo.
Was a pleasure. Was a pleasure.
We'll go to the next speaker. Kiran, please make a presentation.
Yeah, our next speaker is Professor Richard Larson. Professor Richard Larson's career has focused his operations research and systems expertise on a wide variety of problems in both public and private sectors. He is co-author of editor of 6 books and author or co-author of over 175 scientific articles, primarily in the fields of urban service systems, especially emergency response systems, disaster planning, pandemics, queuing, logistics, technology-enabled education, smart energy houses, and workforce planning. His first book, Urban Police Patrol Analysis, that is from MIT Press 1972, was awarded the Lanchester Prize of the Operations Research Society of America. He is co-author with the Emilio Odoni of the widely used Urban Operations Research, Prentice Hall 1981, over 1,000 citations. Professor Larson's research on queues has not only resulted in new computational techniques, example, the queue inference engine, an early example of data-driven research, and the hypercube queuing model, 740 citations, but has also been covered extensively in national and international media. 2 recent papers co-authored with his students have won Best Paper of the Year awards, modeling the effects of H1N1 influenza vaccine distribution in the US. And next one, Value in Health 2012, and the STEM Crisis or STEM Surplus. Professor Larson served as president of ORSCA, Operations Research Society of America, 1993 to 94, and he is a past president of Informs 2005, Institute for Operations Research and the Management Sciences. Professor Larson served as co-director of the MIT Operations Research Center over 15 years. Please join me in welcoming our plenary speaker, Professor Richard Larson. Professor Richard, are you there? Hello. Am I audible?
You are on mute.
Hello, Professor Richard.
There we go. Now can you hear me?
Yes, we can hear you now.
Okay. So yeah, the MIT system is not allowing me to share and to change these slides myself. So every time I want a slide changed, I'll go boop like this. Okay. And Kiran, thank you for helping me with this. So today we're talking about model thinking for everyday life. And during the COVID 2-year lockdown, I actually wrote the book, Model Thinking for Everyday Life. It's published by Informs, and it's available on Amazon. And here the word model is an adjective meaning 2 things. Model meaning exemplary thinking, thinking to be emulated, and model meaning conceptual, so, and sometimes mathematical. So model thinking means both things. Okay, so we can go to the next slide. Can we move to the next slide? How do I do this?
I
1
think,
minute. 1 minute, please. Yeah, it's now. 1 minute.
we'll assist you.
Yeah, I'd like to move to, I need somebody to help me move through the slides.
Yeah, Professor Richard. Now yeah, is it okay now?
Yeah, oh, that's good. Okay, good. So every time I go like this, there's the model thinking for everyday life. We want to change the slide. Boop. Change the slide. New slide.
New slide. Next.
And the publisher is in forums. And so I'm saying hello and to the international webinar on AI, big data, and machine learning.
Next.
So I'm here at my home in Lexington, Massachusetts, the home of the American Revolution. And the first shots were fired against the British less than a mile from where I'm sitting right now at my house. So and there's the Minuteman statue, which is very close to my house. Thank you. I think this is working. So that's not a view from today. That's a view from 2 months ago, what my backyard looked like. Okay. So about the book, what others are saying about the book, filled with surprising insights about the hazards, ordeals, and pleasures of everyday life, revelations that seem perfectly intuitive after Larson has explained them. That's Steven Pinker. You might have heard of him. He's quite famous at Harvard University. And Mark Daskin, who's very active in the operations research area. Like the book, it should be required reading, he says, for any undergraduate course in operations research. And Michael Horn also says some nice things about the book. And I'll let you read that. You can read it faster than I can read it to you. And Sanjay Sarma, a very famous fellow, also has some nice things to say about the book. So a word on research versus practice. And I view myself as a practitioner first and as an academic second. And so to me, operations research, which means research on operations, no pun intended, but that's serious. You're actually going out and looking at things in the real world in which we live. That's research on operations. And my entire career has incorporated both. So I'm neither a theoretician nor a practitioner. I join the two are joined at the hip. Okay, so basically, in many logistical systems, you can speed service by deliberately inserting delays. I'm having some things here which are mind benders. In many logistical systems, you can speed and choosing the locations of wind turbines. The location with the highest average wind speed is not necessarily the one that will produce the most electricity. That's a mind twister. Of two baseball players, Tom and Dick, Tom maybe have the higher batted average in each of two successive seasons, but when the two seasons are combined into one, Dick has the higher batted average. Boy, that's a real mind bender. There's a hidden variable in there, and the hidden variable is the number of games that each have played. Simply moving chronically ill patients from one group to the next can increase the life expectancies of both groups. Can you believe that? You have two wards in the hospital, and Ward A and Ward B, and you move some people from Ward A to Ward B. If the injury and the sickness profiles of the two things are appropriately different, you can increase the life expectancies of both groups by doing that shift, and yet there's been no medical intervention. In most service systems where there's queuing, people have to wait for service, the duration of the wait is usually not the most important thing about customer satisfaction.
Yeah,
Okay. So what I say is in the book, I say the answer is not the answer. It's the process is the answer, the process of thinking, critical thinking skills. So what I try to do in the book is I try to present the way of thinking about life and the world in which we live from a critical thinking skill point of view. And I wrote it not for other academics. I wrote it for the general population. So it's written in a very friendly way. And interactive. It's an interactive book. Every 3 or 4 pages, I ask the reader to take out a sharpened pencil and some blank pieces of paper and jot out answer some questions that I asked them based on the previous 3 or 4 days of 3 or 4 pages of reading that they've gone through. Let's skip this instructive allegory. I don't think we have time for that. Okay. So any day I don't learn something new is a wasted day. B.B. King is one of many people who said that. I think it's also attributed to Albert Einstein. You may have heard of him. So every day we try to learn something new. Otherwise, it's a wasted day. So we get out the sharpened pencils. And we get the blank pieces of paper. And so the book with active pencil and paper, no computer, it requires the reader to immerse themselves in various kinds of problems and to see the world around them in terms of models. You know, when I wrote the book, I made an assertion that the best learning occurs from pencil and paper, not from computer-based learning. But I made that assertion without references. Since I wrote the book 3 years ago, the research has shown that my assertion is correct. That the best thing for the brain to understand something and remember it is for you to work it out on pencil and paper. Okay, so here we go. We have a rainy day. We're in a car. And Mom, how come it always rains faster when you drive faster? You might say, well, why does she say that? Well, she says that because as Mom is driving faster, she has to speed up the windshield wipers on the front of the car so she can see clearly. But okay, so we have to think about this. We have to think about this, and we might have to scribble some things down. Use many sharpened pencils. Think about this, and think about it some more. And then, so in the book, we have a discussion that Mom has with her daughter, which I call discovery learning. And even if Mom knows the answer to the daughter's question, Mom orchestrates a conversation with the daughter so that the conversation evolves in such a way that they discover the answer. They discover the answer themselves in that discovery learning discussion. So this is a key teaching and learning method. And we can thank Benjamin Franklin for making this widely known. By the way, the book's appendix has a full mathematical treatment of raindrops hitting the windshield of a car, but we don't need that in the major text of the book. So Ben Franklin, tell me and I forget, and I guess I'm a little bit guilty of this today. I'm sorry. Teach me and I remember. Involve me and I learn. That's Benjamin Franklin. So there's a Model T Ford. And first of all, if you look at that, you can see the origin of the name windshield. Windshield. It's a shield from the wind. And then the Model T Ford, the windshield was perfectly vertical. So it's a special case of the raindrop problem. So any raindrops, if there's no wind, if the rain's falling straight down, if there's no wind, the only raindrops that will fall on that windshield are due to the forward motion of the car. And the faster the car, the more of the raindrops. So the raindrops are go that way. In the appendix of the book, we actually go into sloped windshields and some more mathematics. Okay. Oh, flaws of averages. So you've heard of laws of averages. Oh, yeah. Let's go back. Yeah. Let's go to flaws of averages. That's the news from Lakewood. Why are we doing this? That's the news from Lake Wobegon, where all the women are strong, all the men are good looking, and all the children are above average. Garrison Keillor used to have a radio program, and that was one of his famous sayings every week during the radio program. And you smile about that, and you say, well, it's impossible for all the children to be above average, right? Well, not if you think about it. Lake Wobegon may be a very intelligent place, and compared to every other places in the state, it's possible that the children of Lake Wobegon are above average, all of them, compared to the average of the state. So the average bus inter-arrival time, you might ask, is that a good service level indicator? Well, let's say this. For instance, we say, well, maybe the average bus inter-arrival time is 10 minutes. So maybe on average in Boston, Massachusetts, on a certain bus route, the buses arrive on average during the morning rush hour and the evening rush hour of once every 10 minutes. So you might think, if I arrive at a random time and they arrive every 10 minutes on average, then maybe maybe on average I show up in the middle of that gap, and maybe I should expect to wait for 5 minutes. Well, that's one way of thinking about it. But then we think about the dynamics of buses in urban environments. And what happens if a bus is going down the route and all of a sudden maybe there are more people getting on than anticipated, or more people getting off than anticipated. So that bus is delayed maybe 30 seconds or a minute compared to its anticipated schedule. And as a result of that, the next stop that it goes to, it's going to be delayed even further because there's been a bigger gap. Meanwhile, the bus behind it, the bus immediately behind it, when it gets to the next stop, sees fewer people than anticipated, so it'll speed up. So eventually, the natural process in urban environments of buses is bus clumping in pairs, and then even higher order clumping. And so the bus delay is not only dependent on the average bus inter-arrival time. So one can think of this as parachuting onto the time axis. So there, you're parachuting onto the time axis. And so let's say as a conceptual concept that the buses show up with a 20-minute gap, and then following that, there's a 2-minute gap. Then there's a 20-minute gap, and there's a 2-minute gap. So you might think that the average gap is, let's say, 22 divided by 10, 11. So you might say maybe the average waiting time is 5.5. Okay, so that you might think that, and but guess what? That's wrong. That's a wrong kind of thinking, because when you parachute onto the time axis, you have a probability of 20 seconds of showing up in the 20-minute gap, in which case your average time of delay is 10 minutes, and you have a very small probability, 20 seconds, of showing up in the short gap. And so actually the average wait for the next bus is 9.18 minutes, not the 5.5 minutes, which the incorrect thinking got us. So there's an example of model thinking. Okay, so let's think of another example. Shocker, half of all marriages end in divorce. A true statement. Let's go to the next daily news. Good news today. Only 1 in current marriages will end in divorce. Both of these statements are true. 1 in 8 current marriages will end in divorce, but 50% of all marriages end in divorce. So there's another mind bender. And to sort this out in your head, you have to do some nice model thinking to straighten out your thought processes. Queuing. You know, I'm an operations researcher, and if you do a Google search and you type in Dr. Q, my name shows up immediately. So my nickname is Dr. Q, and so I've been a Q, fascinated with Qs for decades. And A.K. Erlang, a Danish telephone engineer in 1919, that's more than 100 years ago. Woo! He invented queuing theory. I like queuing. I like the word queuing with a second E in it because it has 5 vowels in a row, and there aren't that many English language words that have 5 vowels in a row. So let's look at Erlang. We see that, you know, in various TV programs like Saturday Night Live and Laugh-In, there's Lily Tomlin, Ernestine, 1950s telephone operator, and she was funny. Okay, and but now we have the emergency number 911, which is implemented widely throughout the United States. And it used to be, for instance, in New York City, if you had an emergency to call, it depended on what kind of call. So police, fire, and ambulance each had their own number. And also each of the boroughs had their own number. And Brooklyn had 2 different numbers, was divided in 2. And there was Manhattan North and Manhattan South. So there were over 20 different phone numbers you had to know in New York City if you had an emergency. And this was reduced to just a 3-digit number, which is now what they call the universal emergency number. So you can apply queuing theory to here. There's more model thinking. And it shows that as the busyness of the area goes, of the queue goes from 0 to 100%, you reach what I call the wall of death. And the wall of death is when you get close to 100% busyness on the part of the servers. The queue is very, very large. The yellow line, which shows a more delayed increase, is when you have 10 servers, whereas the first one is just for a single server. So New York City's 911 system, which as a graduate student, I spent some serious time there trying to help them out, because there were letters to the editor of the New York Times and other newspapers saying, I called the mayor's 911 system last Saturday night, and it rang for 28 minutes with no answer. So I thought maybe I had the wrong number. I called again, and it rang for 25 minutes. And then somebody said, police emergency, may I help you? So I went down there and worked with 2 lieutenants, and we looked through, we got data, and we looked through the order of magnitude change in hourly call rates, and yet there's only a factor of 2 change in the way they operate, the way they allocated their scheduled operators at that time. So basically, I worked with these 2 lieutenants. They did training, and I did mathematics. You apply Erlang's queuing equations and came up with a new process for scheduling the operators. And when that was presented to the police commissioner about 2 weeks later, first of all, he didn't believe me because his subordinates were telling him that there were no problems with queuing delays in 911. And the letters to the editor were telling lies. But the 2 lieutenants were there in the presentation with me, and he said, sir, everything that Mr. Larson is saying is true. And so he implemented everything that we proposed from the Erlang's models in 7 days' time, the fastest implementation I've ever had. One more thing with queuing, I created something called the hypercube queuing model, which is now I think the gold standard in modeling ambulance and police response in spatially distributed areas. And here's an example of the hypercube queuing model applied to New York City, and it shows the response pattern for an ambulance, which is in the lower right-hand corner, and the radii of those blue curves, those blue lollipops, are proportional to the frequency of dispatches which send that unit from its home location to that particular location. And the hypercube queuing model was the first one that ever had the spatially integrated the spatial distribution of calls for service and the spatial distribution of the servers. So critical thinking, our focus is on informed critical thinking, and we're swayed by facts, not emotions, not politics or group dynamics. And a critical thinker is aware of the pitfalls of human intuition, because often our intuition is wrong. I've given you some examples today where our intuition was wrong before we applied our model thinking to it. And so this is I think that my lesson for today is to become a model thinker. And if you go through life and you think of it that way, you even think about groceries and your dog food as an inventory depletion system. You go to you drive in a car and you stop at a red light, and you can play a game with yourself, saying, well, how much is the residual delay until it turns green again? And it's interesting. It's what a queue at a traffic light is one of the few queues where the longer it is when you show up, the less time you'll have to wait in the queue. Most queues, the longer the queue is, means the longer you'll be in the queue. But at traffic lights, if you think about it, if there are 3 or 4 cars waiting there at the red light when you arrive, that means that the majority of the red-green cycle has already gone through. So, so you won't have to wait very long at all. So you can play these kinds of games. And a life example is, here's the Fram oil filter. This goes way back, I think, to the 60s, when it said, you can pay me now or pay me later. You know, replace the oil filter. At that time, I think it was for $6, or you replace your engine for thousands of dollars. And so that's the deferred maintenance. And we have the last chapter of the book, we have a discussion of deferred maintenance. And so deferred maintenance, it's much more common than you think. Your car probably has deferred maintenance. Your house, for instance, my chimney, I have to get it, I better get it inspected quickly because I haven't had it inspected for a couple of years. Fire alarms with fire extinguishers, you want to make sure the fire extinguishers are still working. Yourself, you don't want to have deferred maintenance on yourself. And I used to say my retirement from MIT, but I actually have now retired from MIT. MIT itself, you know, was my home for 5 decades, admits to deferred maintenance on its campus of $1 billion. $1 billion. And so there's a lot of deferred maintenance around, and unfortunately, major incidents can happen, dangerous incidents can happen because of that deferred maintenance. You've seen headlines where bridges will fall down and people are in cars on the bridges die as a result. So deferred maintenance is a major problem. So I asked myself about 10 years ago, when I had gone beyond the retirement age of 65, what are you waiting for? So I invented something called professor post-tenure. And the professor post-tenure is allows one like me to stay involved with MIT and still interact with students and teach if I want to, but it removes me from the tenure roles. So it opens up a slot for a 28 or 29-year-old assistant professor to join the tenure track. And so that's what I did. So thank you very much. That's all, folks. Any questions? No questions.
Dr. Dana,
I'm finished.
Dr. Dana, you are on mute.
I unmuted. Thank you for the most delightful presentation. As a professor myself from New York University, I relate completely, and also was funny that you say that the land from the men are good looking and women are strong, because I always say whenever I do something strong that I am from land when women are strong and men are good looking and children are above average. But you know, that one before was related to Greece, women from Greece before taken to the lake. And I enjoy your talk, and I learned a lot. I learned a lot. Send the link in the chat where people can buy your book. Send the link in the chat so our colleagues can buy your book, and also we can put your book on our LinkedIn, and we can put your book on the website of the European Medical Laser Association. So to try to sell your book, where can we buy your book?
Thank you. Thank you. Right now, the only place to buy the book that I know of is Amazon. You go on the Amazon website.
Send the link in the chat of the conference. Send the link. You must put the link in the chat of the conference.
Oh, okay.
Or
Okay.
give it to Kiran so he puts it in the chat of the conference.
Okay, Dr.
I will do
Dana.
that. I will do that. Thank
Yes,
you.
please do. Any questions, anybody? Everybody? If not, please, let's go to the next speaker.
Thank
Dr.
you.
Kiran. Kiran, if you can put the next speaker on. I enjoyed, because you see, Professor Richard, he is a faculty with great experience, and when he put little things together, it sparkle of knowledge. So I learned several things from your lecture. Thank you. Oh, next speaker, it's me.
Hello.
Good. So
Professor Dana Yok is an expert. Professor Dana Yok is an expert in the field of research in laser for biomodulation. Her academic background includes a degree in education from the Academy of Distinguished Educators in Clinical Teaching at New York University, PhD in laser therapy, and MSc in biophysics and cellular technology at the University of Cologne-Davila, Bucharest. Professor Yok has served on the board of editors of the International Phototherapy Association of Japan. She has conducted clinical trials for photobiomodulation techniques with different technologies and has published this research in peer-reviewed journals as well as presented at international conferences. She was awarded the prize for Best Research Paper at the Florence Laser Conference in 2002, as well as the International Academy of Laser Medicine and Surgery on Bone Regeneration in 2015. Professor Yok has recently joined the study group for artificial intelligence within the new European Surgery Academy. She sits as a delegate for universal healthcare at the United Nations and is a fellow of the UK Royal Society of Medicine. Her first degree is as doctor in dental surgery, followed by periodontology, and Dana is a philanthropist. Her work brings her to Africa to help the cause of the children's victims of gender-based violence.
It's a great honor to be here. Let me share the screen. So during my master's in biophysics and cellular technology, we got into all what it is related to statistics. And then during COVID, I got in all that, and concentrated more on health, public health, than into individual practice. As a periodontal surgeon, I have seen 25 years of patients. During my PhD degree, which was in lasers in medicine, I again study so much about research procedures, and whenever it happens that I need it in any field, the learning on research really helped a lot. And now I want to show you something that's really interests me as a private person, right? Can I show you? So I'll show you anyway. This is it, my last project. What did I do? I painted. These paintings are my work. I painted a temple in France, in Cannes. And there it is, the commemorative plaque that says, Dr. Dana York and her significant other donated for their parents. So I'm very proud to have done that. Then about 5 years ago at NASA, New European Surgery Academy, Professor Michael Stark put together a group to study artificial intelligence in medicine. There it is, this first computer for artificial intelligence. Then there it is, this first program, first code. And then what it is, the definition of artificial intelligence is the intelligence of machines.
Professor Dana,
Yes.
sorry for interrupting. Could you please share your screen?
Oh, my screen is not shared.
No, it was not shared.
My screen is shared.
Yeah, could you please stop and share the screen again?
Yes. It's good?
It's perfect now.
Excellent. So let me show you first one. This is the first computer. And then this is the first code. And then this is the definition, the intelligence of machines. And then let's go through the history. 1956, artificial intelligence gets the name. 2012, we get to learn deep learning. In the 80s, in the 90s. And so on, then John McCarthy, then Marvin Minsky, then at MIT, and then Alan Turing. We mentioned him because we love him so much. And Alan Turing did a competition between human and machine. He did the test. The machine always won. And then in the history from the 50s, then we have artificial intelligence. In the 70s, machine learning, then deep learning, and then finally we got to today when we even gonna evolve from artificial intelligence, as we found out today, to biological intelligence and so on. So what it is this difference between humans and machines? Humans, memory, perception, problem solving, decision. Machines, language, statistic. The statistics solve problems, computer vision, dialogic, domain data, and machine learning. Research in the 60s and 70s produced the first problem-solving program. And then while was designed to apply organic chemistry, basic program was MICIN. And then from that, internist and CASNet and so on to achieve a routine AI. AI chat box. Then we have this artificial intelligence neural links to all over to life science, medicine, chemistry, science, materials, mathematics, and so on. So what is that deep neural network? Is that like storage in drawers, input layers, then multiple hidden layers of storage of information that gets to lead to deep learning. So we have popular AI languages like Python, and then we have TensorFlow, PyTorch, Keras, NLTK, and OpenCV. Then we have a marvelous list of programs like Google Assistant and ChatGPT, and so on. Then we have AI screenwriter. Then we have the AI comedian that can find you all the jokes you can need. Because in life, boost of happiness is very important. Then Java, then R, then so on, included Apache Spark and Stanford Core NLP and so on. So in cybersecurity, we have ongoing learning, discovering unknown threats, vast data volume, improve vulnerability, enhance overall security posture, and better detect and response. Natural language. And we mentioned Noam Chomsky, who created generative grammar. And then on and on, speech recognition, custom search online. And then we get to have the structure of AI. So we have the core of AI, and from that we have the properties, ternary, binary, unitary, and then we have atomic scale, nanoscale, microscale, and microscale. That's the power of material science. Design, all this code. Now, in my case, in medicine, as for the past 5 years, I've been going to several universities around the world, to Ahmedabad, to Tamil Nadu, to Kerala, to Tanzania, to Congo, to Uganda, to Dubai, to Abu Dhabi, to Oman. And wherever I went, and the most important is online, because it's cheap, is inexpensive, and we can learn so much and have knowledge. The most important is inexpensive, and knowledge is so important. And now I'm going to enter in the field of medicine. AI using diagnostic is so important now, because the machine, MRI, CT scan, all kinds of scans, they get the data, but the final is the doctor that goes and read all the images. For example, my mom recently, let's pray for her health, got scans. So the machine, the AI, gave 2,500 data, and then the diagnostic was detected, and they detected anomaly, and then the doctor got to read out of that from a little bit of data and got to give us an image and diagnostic. And then another doctor read what the doctor said, no, I want to see as well. So finally, we can always pull the plug. In diagnostic is a huge, important application of AI. And then we have the 3D scan, and then we have the guidance for patient as a GDS for dental implants and for any implants. And then we have the assistant, the employee, as we say, the secretary. That's so important as well, the administrator. Now AI became an administrator. I can get phone call answers, message answers, address giving. You see when you call the bank. Same is in a clinic, in a hospital, in the app of New York University is just amazing. Then we have the photo tagging, we have all these in social media. And then we have robotic surgery. So imagine you have this surgeon, amazing surgeon, Michael Stark, my hero, the president of New European Surgery Academy. I look up to him. So he's in Frankfurt doing the surgery. And guess what? Through robotic surgery, another team of surgeons is in Afghanistan. And he does the surgery at a distance through this robotic AI. And then speech recognition is important, human speech. Where is the most important use of AI? In the orphanage in Tanzania. Here we are with our adopted children. This is the Mother's Day, and these are my adopted children from Tanzania, the Agape Orphanage. Why is AI important for them? Because AI nurse in the orphanage will respond in Swahili, Mambo, Poa, Asante Sana, Haribu, in Swahili to the questions of the children. I have tummy ache, and the nurse will respond in Swahili what to do. And then another machine pharmacy will dispense the medication needed by the child. So in the middle of nowhere in Tanzania, that will be the best use for AI. And finally, after the product is created, it's not expensive to use it. It can be put all around the world for free, for free. That is my most important thing that moves the heart. Okay, I'm gonna go to the next slide, 1 second. And so far, anybody got any questions? No, I'm going to go to the next slide. In the use of in the use of AI, the nurse is fantastic. The nurse is important, right? How important is our nurse? But what if we have an AI nurse that comes for free? Or imagine you have to carry person, the carrier in the hospital. What if the nice nurse, they are overworked and underpaid, and they have so much to do, and it's impossible to carry somebody. So what if we have an AI robot that will carry the patient? But what are the challenges of AI? First is hard to integrate in projects. Second, you need technology projects, experts, too expensive sometimes. And I'm very grateful to the experts. I'm grateful to Bogdan that spent about 5 hours with me the other day. And I learned a lot from him. You're going to hear from him, and we'll be in for a treat during the panel discussions. Technology is expensive and untouched because you need the learning. Then technology can be mature and problems have to be solved. And also funding is important. For that, I tell you, as I will tell to my child in the heart of my family, because I consider you my family. Apply for funding, apply for grants. Either they're government grants, public grants, science grants, wherever you are, local grants or international ones, so that you can spread the word about your technology. There is shorter time of wait, there is removal barrier for treatments and boost efficiency. And then we have learning technologies, and then we have 75% of the patients that say, yes, I want my doctor to have any technology that it is. And imagine if I am in the hospital in a bed, I would like to be hooked at any AI machines possible that would monitor my blood pressure, my heart, my insulin, my stress level, my everything, until the hardworking human nurse that will not be there to immediately manage the level of medications I need if I would be in a hospital bed. Then now, more than 86% of the businesses, they use AI. So you think of social intelligence is used by Kismet and this and that and the other. And then we have perception. And then we started to have this emotional intelligence. For example, my significant other told me yesterday that is some emotional thing that if that AI now that speaks with a 7-year-old, it will speak like it would speak to a 7-year-old's needs. Then the medical technologies go to genomic, to administration, to robot-assisted surgery, to deep learning, to data log, to rare disease, to algorithm, to diagnosis, to the large technologies that go to solve any problem in healthcare, to mental illness, and to store database and differential diagnostic. What is the thing to do? Increase utilization, decrease patients boarding, reduce length of stay, and optimize staff level. Google, DeepMind, Tencent, Intel, Elon Musk prepared the first robot surgical implant, Neuralink brain chip. Now we are trying to work on a chip for a GPS as well. Don't get your education from the detail man, like I bought this perfume and the shop girl will tell me how this perfume works. Learn. You went to school, you go to a master, you go to a university, you are an engineer, you had a PhD degree, and get your knowledge by well research everything and study. Be aware of deepfake. As Dr. Antonio said, deepfake is in all the television giving us fake news. Be aware of deepfake. It's everywhere and it's just to make brainwash and is not good. Think of the legal and ethical consideration of AI. Now the robots have rights and it's cognitive service and accountability and bias and planning and transparency. So we see everywhere this hire your virtual assistant. It's great. You're not there, but he writes, Dr. York, office, how may I take your call? And then you are on the beach and you take the call. It's too easy. Life becomes too easy with the AI. How smartphones use artificial intelligence? Predict, route, learn what you like and keep giving you. I saw even they know how I dress and they know how fat I am or how slim I am. And they give you whatever they think you need. It's just like programs, really. It's no miracle. It's just you guys are really smart. Executive, improve clinical outcome, operation performance, administration, financial outcome, and consumer engagement. So for healthcare, it got a boost of use everywhere. Algorithm, GPT, we know of that. How would you feel if the healthcare provider rely on their medical care for AI? Comfortable, uncomfortable. It's true that you have the AI and you have the computer, but you must keep paper trace. You must save the data. That's important. How would lead to healthcare outcomes for the patients? Better, worse, three. Definitely the AI use, the technology makes better outcome for the patients. Advantages of intelligence artificial: human error reduction, availability, invention catalyst, use in daily household tasks, better workflow, medical applications, better security, solving complex problems with quantum computing. Disadvantages: limited risk assistance, efficient in repetitive tasks are still advantages. easy deployment, better data analysis. And then disadvantages, cost can be high, death, we don't have enough talent, lack of practical product, and potential of misuse. In summary, embrace artificial intelligence. It can be just as programmed by somebody. Remember, it's still artificial. You can block it, and somebody made it as a super program. It's wonderful, but we can still pull the plug. Be afraid of deep fake. Put it in all together. We congratulate the pioneers in this field. Let there be light and knowledge everywhere. Please don't be deadheads, arrogant doctors, and be curious and learn. Now, let me show you my recent artistic program that I'm so happy to show because it's my other part of life. I am a painter. And this is my artistic painting that is just finished last month. It was a sacrifice, and I am so proud. Look at this. This is an example for learning. So first I did everything on red because they gave me artistic freedom. And then I arrived at then somebody, nice elderly gentleman said, "This is a young temple. We are modern. We would like something modern." I didn't say, "No, I made it for you. You have to accept it." I said, "What would you like?" "I would like on blue, and I would like something like Chagall. I would like something like this, like that." I went home and I got another piece of glass and I painted that window until I got to this result. When I returned, I put it on. The nice elderly gentleman said, "Bravo." Bravo. That means congratulations. And you see, I was patient and I wasn't arrogant and I didn't say, "Oh, you must accept this." No, until he was happy, I worked on it and until I got to that result. And until I got from here, which is me, as I am a university professor, on the ladder, I got so much pain in my knees to make this star in gold. But then when I did it in gold, everybody said, "No, it's too much, the gold." And I made it platinated, you see? I made it kind of like gray with a little gold under until people, they said, "Bravo." But then also they said, "These look like sarcophages." And then I said, "No, they look like vaginas." And then I covered with the flowers. And then I uncover and I said, "No, they're just flowers." Sometimes you have to stand up for what you do. Sometimes you have to be flexible and to say, "Okay, let me learn what you want and I'll do it." So this is another one of the paintings. There you go. I show it to you. And please let me know if you have any questions. In the end of the presentation, I want just to put a last little video that I like so much. 1 second. 1 second. There it is. So another thing I want to say, we must stay together and united, and we must learn to communicate. Dialogue is the most important. I want also to invite you on the 12th of October in our most important event. Why is the most important? Because it's going to be live and it's going to be in New York, and we get, if is possible, we get a chance to meet each other in real life. Like I've been participating as a chair for the conference is organized by Kiran, and at the invitation of Professor Francesco and Tony, and it's been 3 years, 4 years. So in the end of the presentation, I'm going to put the last of the, there you go, this video. Now, this is the photobiomodulation, and you might think that this is going to be sometime in the future. No, this technology is being used for 34 years, and is the I used it for 34 years myself, and it's been used since 1964. And it's called photobiomodulation. So thank you for your attention, and we will go now to the panel. The panel members, please come and open your phones. We wait for everybody to come in. And any questions?
I have one question, if I may. Well, first of all, thanks very much for your presentation and also for sharing what your passions are, because we are all made by logic, passions, and so on. So thank you very much. I really appreciate it. I have one question. So basically, when it comes to AI applied in medicine, one of the biggest challenge, perhaps the biggest challenge, is to explain what is the algorithm logic behind a certain diagnosis and behind a certain output for some patient, all right? Because sometimes when it comes to deep learning and to very complex algorithm structures who are going to make some decision rather than another, it is very hard to explain and to be at 100% transparent of why a certain things. So would you prefer a machine learning model which is going to be extremely effective, but at the same time, it's very hard to explain why this model has taken some certain diagnosis? Or would you like to have a machine learning model which is less effective, so which has an accuracy there is going to be fewer than the previous one, but it is explainable and it is clear with a decision making which is explainable to every kind of doctor? Because for instance, if I'm a patient, and I hope to not be, of course, and someone tells me that a machine learning models has come up to a certain conclusion for a particular diagnosis.
Antonio,
Yeah.
when you make a question, I learned that at rabbi school. I'm learning to become a rabbi too. When you make a question, make first phrase, second phrase, and stop.
All right, thank you very much. So would you
Okay,
prefer...
I'm going to respond now.
Thank you.
What happened? To create an AI, we gave information over 30,000 response to diagnostic, over 200,000 of the same diagnostic, yes, of the same molar. Let's say we have a premolar, And this is the diagnostic of that premolar. We collect the data of 100,000 diagnostics. And then after that, as putting that diagnostic into the database, we create the logarithm of what that diagnostic gives, and we start from that. And final decision is not taken by AI, is not taken by the machine, just to a certain point. Then the human being come and move, okay, we want this cuspis to be like this and this cuspis to be like that. Okay, you said that this is severe aortic insufficiency, heart insufficiency, but no, I don't believe it. And also in medicine, we have this and this. We don't take only one diagnostic. As well in diamonds evaluation, for example, with my laser, because I'm like Darth Vader. You know me, I'm Darth Vader. I'm also a detective, and we'll find out who was that person who threatened the other. I'm going to tell you detective stories because of my research experience. I detected theft, I detected crime in the past, because there it is. We learn research. That is research. So what we did, this black card is a black diamond that I cut it myself with a laser. And there is a machine, and the machine gives a diagnostic. Is it a diamond? Is not a diamond. Is it natural? Is not natural. So from that, you put the logarithms, you put data, and you make the cross data to get a diagnostic. Cross data. And then final is for medicine, final, you get the human. Hold on, what is machine? Did the machine went hazardous rumbling? No. Or there it is. Bogdan, what do you think? Bogdan.
About AI in medicine, well, in my opinion, AI in medicine can bring multiple contributions actually. Why? Because in medicine,
What logarithm is used for AI medicine?
actually, we divide something internally, like at our company. But I wanted more to address like the pain points that we identified in medicine in Europe and in the UK. Like, how do you make use of multiple sources of data, noisy data, unstructured data? Like, AI can help you organize this data. AI can help you make sense of it. Like, this is the best use of AI, like helping you make sense of your data, managing your priorities, being able to even see data that you never knew was there actually.
The more
This
data you got, the more accumulation that the previous histories of that you got, the
yes,
more you get to a better response.
exactly. And you identify trends, patterns like that.
What do you think, Professor Richard Larson?
Well, I think a lot of what we call AI is it's an arbitrary label. For instance, over a decade ago, I invented something called the Q inference engine, QIE.
You invented that?
I invented the Q inference engine.
Oh my God, you're the inventor of Q inference engine?
Q inference engine. And yeah, it's published. And I right now view it as a curiosity, but it basically from partial information about how the queue is moving, it makes an inference about how long the queue is and dynamically changes it. But here, the reason I mention this is if the Q inference engine were invented today rather than 10 to 15 years ago, it would be called AI. It would be called artificial intelligence. So this AI label is a little bit arbitrary, and because things like that which would be labeled AI were invented years ago, and we didn't have that label. So anyway, I view it as a trendy label, which maybe will persist for a while and maybe will go away. My preference is for HI. HI is human intelligence rather than artificial intelligence.
It's true, but oh boy, this artificial intelligence makes the life easier. Like this computer thing, like for me, sending 2,000 email at once to distribute an information, it's amazing, you know, or whatever it is, gathering so much data. It's so amazing. Dr. Ricardo, what do you think? Where is Dr. Ricardo?
Yeah.
Did we lose him?
I'm here. I think this is a good point, Professor Adana. Is the possibility, I think, work with artificial intelligence gave us a possibility to work with different kinds of data. You can work with, for instance, regular data, but you can work with, for instance, textual information, unstructured data from internet, from LinkedIn, from exams, the doctor's exams, or even from sites. So you could do web scraping and bring this data and analyze this data in the single environment. I think this is a good point that we have in artificial intelligence, not only the algorithms, but the possibility to work with different kinds of information coming from different granularities. So here, for instance, we work a lot with energy companies that they work with information coming from aeolic turbines, and they need to have information from aeolic turbines, and they need to have the information from customers in internet. And so a lot of different kind of data, and using artificial intelligence, we can combine all this data in a single point and analyze. So I think in a regular way, it would be difficult to analyze this different data without artificial intelligence. For this, I think we need to be more open to this kind of thing, because it's very powerful.
We now do a photobiomodulation device that is like an therapy device, right? For pain relief. So what do? We try to create a device of this size with a diode light that you would put it somewhere where you have the pain and will remove the pain. But for 34 years, I've been working with a photobiomodulation device like this big, and inside is a computer. And in the computer, they give the doses and the protocols, how many hertz, how many joules, how many watts, for 1 million of procedures. And then that is also artificial intelligence when you press a button and everything is there already set up and you just use it. But in a way that makes you stupid because you think you know, but actually you don't know what happened behind. So for that reason, we try to segment and to get the bottom of it. And for that reason, it is good to apply for grants and to get the research together and the funds for doing what you do. Like Dr. Antonio, I think is the youngest from us. And I am proud to say I am more than double his age because I am 54 years old. But you know what? Thank you. I don't look. Why don't I look? Because this light photobiomodulation that I use to treat the patients. Patient is here, me treating the patient for, let's say, 30 years, because 4 years ago I stopped seeing the patients. But I still research and experiment lots of lasers. Because of that, the photobiomodulation I was exposed kept me young. And a lot of girls my age, you see, I am much younger and happy because this energy cause this protein C reactive to enter in the nucleus and stimulates boost of oxygen to the membrane, and channels of magnesium, potassium, and calcium go out, in and out. So the best use, it can be used immediately to remove pain, and it replaces and makes a revolution in the medical field, because replace Advil, Doliprane, and NSAIDs, replace medication. Dr. Ricardo, what do you think?
Yeah, no. It's fantastic what you said. I fully agree. I think now we have a broad of possibilities using artificial intelligence. My experience here, we are starting work with agentic AI. That is a possibility to not work with artificial intelligence to identify things, but to act by ourselves. And this is, I think, is the future will be amazing, because we can, of course, using this in a responsible way, as I mentioned in my presentation today, in an ethical way. So, but I think it's totally. I am very optimistic with the use of artificial intelligence in the future. So I'm very optimistic with this.
I want to ask Dr. Cohen if he is active in the link. He is in the room, but he might not be active in the link, and I don't know how to ask him to come in. You know, he is also very involved, so we'll ask for him to benefit from his work tomorrow. Tomorrow is good. Now, I want to ask you all, how many of you ever apply for a grant? None of you? You did. We need your help, because we just got our SAM approval. We got our SAM approval and cage, and we need your help if you want, if you have the time. Dr. Richard Larson?
You ask how many people have applied for grants?
Yes,
Yeah.
I asked you to help EMLA with the applying for grants, and Antonio, and Bogdan, and Ricardo.
Okay. No, I'd be happy to. I have a question about AI. How is AI distinguished from statistical inference?
Can I put my point of view, Professor Richard? First of all, it's a pleasure to talk with you. I think when I talk about, because I teach my students the data science using both point of view. One way that I use to differentiate these words is related with when you work, for instance, with a classical statistics. You are not necessary using a measure of error, okay? But when you are using artificial intelligence, for instance, suppose that you are using a gradient boosting or a random forest or a neural network, for instance, you are comparing the observed. You need to have an updated metric to be updated and realize if your observed and predicted observations are being closed, okay? So when you are working with a classical statistics, you do this in only one shot, okay? But with artificial intelligence, you do this in a recurrent way. So the idea with artificial intelligence is try to minimize this measure, okay? So I think we can convey very well statistics and machine learning, but I think the most important the point that differentiate these two blocks is that in artificial intelligence you try to minimize the error metric, okay? Doing this in a recurrent way, and when you work with statistics in a classical way, you do this in one shot, okay? This is my point of view.
Okay, but I didn't say classical statistics. I just said statistical inference. I didn't mean to limit it just to something you get out of a textbook of things that were invented decades ago.
Put Cohen, Cohen. It's the same thing. You get together a data and you put it together. Just with AI, you got more data and more data and more data. It's the same.
So
really
it's a fancy way of statistical inference.
It's a fancy way, but it got
I think
also
so. I think so. Yeah.
code. It got more code. It got little bit more and more. Like, let's say 1,000 times more information in that statistic. So you get a statistic, minimum of statistic for 20 subjects, right? But then it's all the same. It's a trying to put light so people understand. I'm trying to get to ask a question to Dr. Cohen, which I wanted to know because we are in for a treat. He's an amazing scholar. He's gonna be in tomorrow, but he's not there. Antonio.
By the way, Dana, yeah. May I have the chance to answer because I do believe there is a really good question, because without what we know as data and what we know as statistical inference, we wouldn't have AI at all. So this is maybe perhaps one of the smartest questions that I have ever heard, because those things are similar since they are consequential to each other's. But the main difference, in short, and I would love to be as much clear as I possibly can, is that statistical inference means understanding data. So we are understanding that kind of data. Meanwhile, AI means making smart systems using data that we understand with statistical inference. So this is the main difference. Basically, if we understand data about consumers from Amazon, let's say just one of the many examples that could be, we understand why a data subject, which can be myself or other people, make a certain choice. Meanwhile, with AI, we build a system based on that understanding that we have from statistical inference to drive me to have a certain choice rather than another. So it's building something above the understanding of data that comes from statistical inference, which is one of the most important things in AI. So it's about making smart system using the understanding of data that we do with statistical inference. This would be my answer, but this will imply also other things in the world, because with AI that makes a smart system by personalizing our choices, we say goodbye to a kind of doctrine of in economics that implies an aggregated demand and an aggregated offer, because we have an individualization of a data subject from a personalized offer and a personalized demand. And this is applied also in medicine with a personalized diagnosis and a personalized treatment of a certain patients, because there is the understanding of the data which are going to describe that data subject and or that person, and then AI is going to build smart system to make certain choices and to drive their sources and to drive our choices, basically. So this would be the main difference. Thank you very much for your question, because it made me think, actually.
All is statistics, finally, and explanation, language, a mix of things. Dr. Cohen, what do you think? Dr. Cohen?
Yeah, but I think I have a problem with my micro. phone?
No, we can hear you well.
You can hear well.
Yes.
So first of all, about I didn't follow all the everything, but what I can tell you is it's very important in medicine with AA to consider the biais. That means when you have a lot of data, even you have influence of the influence of the data that are induced by the political information or social information that you put in. So as I will say, for example, if you are if you put information like information with I have a good example which can be used to be understood about social things. For example, if you put if you ask who are the 4 foundation people who gave the Constitution in US, actually it gives you a black woman, young black woman, an Indian, white man, and another white man, and which is absolutely false because it was 4 old white men, and it's because of the influence. And in medicine, you need always at the end, actually, I mean, to have the human touch for diagnosis. That means even in radiology, you can get 80% quickly with the artificial intelligence information data, but you need really to be for the exact diagnostic human touch. I think in 2 years, maybe it can be quite much 95, 99%, but actually it's still like that. So that's what I can say.
Question about the 80%, and you say that's AI. To me, it just sounds like statistical inference. You say have the data and you work on the data. You're making inference from the data. Why is it called AI?
Just a minute. I have a problem with my microphone, and just a minute.
Bogdan,
I need.
Can you respond to that question? Bogdan will respond to that question. Please, Bogdan, respond to that question.
Yes, like it's called AI because basically like it has the reasoning behind taking a decision. Like you can actually open a log and check a decision tree and see how he came up to that decision based on the information at hand. That's why it's called AI. I hope I managed to answer the question to an extent.
What does that mean? What does that mean?
That it reasons, it has like a neural network, like a human brain, and based on the information.
How is the reason, the human network? How come? So is statistic plus is reasoning. How?
Yes. Well, this is the magic of AI. Like it can actually draw these conclusions. It can reason this, and with the information at hand, and this is very important that you have like correct information. It can make predictions. It can make calculations. This is how it works. This is why it's named AI.
I was very surprised when yesterday Bogdan showed me how he created a gorgeous, sexy girl that opened the door of a restaurant, and she says, "Come inside," as a publicity for a restaurant. And he created that girl with AI, a human being. You think she's real, but she's not real.
Yes. Yes, it's like one of the lesser. I
You
don't
see,
personally
this is
prefer to
lesson to
use
learn.
AI in this
And
regard, like
he did it.
basically.
And then he created, and he created this amazing English accent, sophisticated voice. And in the sophisticated voice was this that was a narrative for a documentary, for history. And it was also created with AI. So imagine how much saving of time, saving to put that information. But also, what did you tell me, Bogdan, that it is, you have to be careful because it will go, for example, you said this history documentary was for one country and started to go to another country. So
Yes,
it can
it's the
be
point
so
of
wrong.
confluence.
It can be. So when do you need to stop?
You need to be very careful when training an AI model because basically it can begin to hallucinate after a point. Like it's something that you need to be very careful when doing because like you need to see when training, let's say on data, for example, because mostly what I used was data, historical data, economic data. To an AI model, it doesn't matter. But
And
when I give him data,
create,
a set
to
of
create,
data that he doesn't know, yeah, sure. What
and
did
you
you want
use
to say?
data to create that sexy girl that moves like this, like that, and goes to the door of that restaurant.
That was just a thing called prompt engineering. This is something that also people need to do a lot. Like personally, for me, I prefer the fine-tuning part. I will explain the difference in a second by mentioning prompt engineering is like when you have already an existing AI model and you try to explain to him what you want to do. You tell to him like, please do this statistics, please create an image, please create something. Basically, it's ChatGPT in a box for us. But fine-tuning is having access to the code, to the back code, and literally creating new instances and giving him instructions and refining this model, making it more accurate, making it more fast. This is fine-tuning, having access to the code per se. What I did with that girl when I created an image, I did only prompt engineering. Like I had a system on my computer, I described the image, and it became reality. But this is fine-tuning basically when you have access to the code. You are on mute.
Did that respond your question, Professor Larson?
Well, I think he could have done that if the word AI didn't exist. And I mean, AI happens to be a trendy label, but I don't really see how that explains a lot of things.
Because finally, intelligence is not artificial. Everything was done by somebody, right? Now, finally, everything is placed in that box, in this, in that, is not artificial. It's storage of information. It's storage of that's all it is. But that information with hardworking hands was put in by somebody before it was so much that they said, that's it, we have so much information here, we will call it artificial intelligence. But some
Yeah,
really
but see,
hard.
I call it statistical inference. And I'm not convinced. I'm not convinced that there's a need for another name, but maybe there is.
Antonio, you want to defend the artificial intelligence name? Because I don't defend. I agree with you, Professor Larson, completely.
Okay.
Antonio, you want to defend?
Thanks for your question, and I don't have to because like I do not have to build a defense system for anyone, particularly for AI, because it's an emerging technologies which is going to be understood step by step by including myself, because I teach AI, but I am learning day by day and second by second always new things, and I had some doubts that professor has, with whom I have the honor and the pleasure to talk, because I have to learn from him a lot. So I have to learn from him many things, since he's older than me, and he has done much more things than me, and it's an honor for me to speak with him. And by the way, it's not about defending AI, it's about explaining what I know. And I myself had the same doubt, because I thought by myself, but this looks like statistics, because it's not something like totally new. Maybe this could be just a new brand thing that people are calling AI, just to make some money out of it. And then I studied, I read many informations, particularly about neural networks, because the main goal of AI is overcoming the Turing test that was published in computing machinery and intelligence in the 50s, in 1950. And this Turing test had the goal of evaluating an intelligence of a computer, and an hardware was considered to be smart if and only if was able to make humans believe that he was human. All right, so maybe this is what it's all about. And in 1956, at the Dortmund conference by John McCarthy, was invented this term of AI by contemplating the possibility of a machine that thinks. So if a machine can read data, it can understand data, this is called statistics, which is the most important thing. But if a machine can think and can make new data based on that data which has read, is called AI. So this is the main difference, like the manipulating phase of making new data and not only understanding what those kind of data are. For instance, I am a buyer, and I buy a couple of different breads. All right. When I analyze with statistics, it's very important to understand there are both those two couple of different bread. Let's say bread A and bread B, but with AI, there is the computer which tries to understand why I have both A and B, and how it could make me buy again A and B. So it's a kind of a different level, and it's a kind of human dealing with data, which is kind of understanding. So it's a kind of second step after we have seen the data. So it's hard to understand in the beginning, and I had the same doubts, but that's pretty much the difference. A smart system is AI, and statistical inference is understanding the data. That's pretty much it. But those things are combined, because without statistical inference, it would be just about impossible to have AI, because this is the most important thing. Thank you.
I think what Professor Larson's trying to say is that this so-called AI is been there since 50, it's been there called as different names. And it's been always AI. And now, but you see, AI, it's sexy. So then there you go. Instead of saying statistical interference plus logarithm, we say AI, and that's it. You got a name. And then you see, only about 2 years ago, a lot of funding started to get into the artificial intelligence again, because it died for a while, and then they reinvented. I give you an example in my field of photobiomodulation. When I started to work with it, I was 19 years old. My teacher gave me the laser in the hand, and I put it on the patient. I had no idea what I'm doing. I was just an operator. It was called low-level laser therapy. Then it changed to cold light therapy. Then I went to Japan. It's called phototherapy. Then I went to Brazil. It's called laser therapy with infrared light. Then I went in North America until they got to the name photobiomodulation. So it's the same thing, different name. You understand, Professor Larson, what we try to say?
Yeah, what you described is a bunch of trips and visits to different places, and the data, the results of
I'm
those
describing the
trips. So
name,
basically,
the name
basically
of the
all
same procedure.
the
Is the
information was
name.
data. The data,
Yes.
statistical
So,
inference from those data.
right. So artificial intelligence got the name statistical inference before, and now they change it to artificial intelligence.
I know statistical inference doesn't sound sexy. It sounds like it's something out of the 1930s, but I'm not referring to statistical inference that you get out of a textbook from the 30s or 50s or 80s. I just think AI is a label which is not that meaningful.
If you want, Bogdan and Antonio can stay with you showing this engineering that they make it to be called AI. You know, those amazing logarithms that they are working with. Right, Rodolfo, what do you think? Can you explain why AI is different than...
Okay, the question is really sharpening. On the basis of the elaboration of the information, there is still data. Then technology evolve, and according to the evolution, since the end of the Second War, we are going to find new name, but practically the way of working, it is centered on data and the way in which the data are elaborated, so on statistical basis. Till the moment generative AI arrives in November 22, probably artificial intelligence was not so sexy. And so all the people talk about statistic in a more proper way. Then, according to the new arrival of some machine that through AI generates something new content, we start talking about generative AI. So the original scope of the AI that was predictive evolved in a new scope that was generative new contents. The way in which the data are elaborated is slightly different, especially if we consider audio, if we consider video, or if we consider code. From a proper point of number, for sure it is statistical inference. From a point of view of generating a new video, it is not only statistical inference, but there are also some, let me say, qualitative choices that are made in order to influence the large language models to produce a different output. And according to our, let me say, prompt, the final output can change. So we are able, through our prompt, to influence the way in which the machine combine the token in order to produce a different output. This is my point of view. So fully agree with the professor that till the predictive AI is practically statistical inference. When we move to generative AI, something is gonna changing, and now with the agentic AI, things change drastically. This is my point of view.
Dan, what do you think?
Like, what's the difference between AI and statistical inference? Well,
Yes.
I believe like one critical point why AI is called AI basically is that anyone can use it. Even someone that isn't like a business analyst by profession even can ask a question in natural language. Like, hey, I want to know, let's say I work for the Coca-Cola company and I have sales in a city and I don't even know how my data is structured. Personally, I don't know anything about my data at all. And I'm just asking a question in natural language. Please tell me, how can I sell more cans of cola in this city? Please tell me, how can I perform better at my job? And the system, the computer basically does these computations for me. He knows in which order to do them. He knows how to do them, and he just gives me a straight up answer. Like, I think this is the game changer and why it's so wide used and why a lot of companies now want to implement AI.
But if you're just using the data, and you said we're going to analyze the data and put it together in different ways, to me that's a brand of statistical inference.
It is. It is. The difference is that you don't have to you don't have to know anything about what you're doing. Basically, even an employee from the warehouse can jump to these conclusions and have the final answer. Basically, like, it makes it accessible for everyone.
The
to do
game, the
this
game
computing.
changer was the LLM that evolved to chatbot AI, allowing the mass of the people to use AI and therefore statistical inference through a textual language.
Yeah.
This was the great change that make AI a sexy term, but practically the machine inside use statistical inference. So practically all of us has a piece of right, and combining all the piece of right, we arrive in the final outcome that is a democratization use of statistical inference.
It sounds like we're in wild agreement.
True.
We can hear you, Dana.
Say again?
No, I said to Dana that we cannot hear her because I see that
she's on mute.
she's muted. Yeah.
I am so
But I love
grateful.
this.
Yeah, I can help her.
I am so grateful to have such brilliant minds in the panel today and to answer questions. And we still will go to literature and we'll go to articles to clarify some things, because that is the most important about research, to get answers and to go and research some more. Now, we will close the panel session, and thank you so much. And please be present for the panel tomorrow. We'll have the continuation of the panel tomorrow. If each one of the panel member would like to say a final word, please.
I just want to thank everyone for participating today and for inviting me. This is a huge honor. And you got my brain going earlier in the day than I usually am. So thank you so much.
It's my pleasure. Thank you. Thank you very much.
Thank you to all panelists for the great discussion. Thank you very much.
Thank you very much as well. It's a pleasure to be here and an honor to meet you all.
Thank you. Now we will invite Dr. Duvuri Venkata, and we'll ask him to unmute and be presented by the organizer. Dr. Venkata, if you please kindly present yourself.
Yeah, thank you for the opportunity. I'm going to share my slides. 1 second. And let me go full screen. Thank you, everybody. I hope you can hear me.
Sorry for the interruption, Duburi. Sorry for the interruption, Dr. Duburi. We will introduce later on. Okay.
Dr. Venkata Duvuri is the founder of Series Mindshare, AI apps research company, and recently a director of data science at Oracle Corporation. He results in oriented data science, business, web, and marketing analytics leader with over 12 years of experience in data science, business analytics, digital media analytics, and web marketing optimization with leading internationally recognized corporations. Additionally, he has 10 years of software engineering experience and a top business school MBA. He has experience in management of onshore and offshore teams, as well as leadership experience ranging from director to manager at Fortune 100 companies, including marketing agency. He is a cross-functional leader and a subject matter expert in machine learning. He has improved ad performance to the tune of $10 million at University Technologies and $7 million at Oracle leveraging deep learning, Spark MLIB, and TensorFlow operating on big data. He has driven improvement in business and online marketing outcomes to the tunes of several million dollars at eBay in Pride Retail Media. AT&T Cricket Wireless and crushes several terabytes of data at Apple Corporation. He holds a master's in computer science from University of Massachusetts Amherst and a MBA from University of California Davis. Additionally, he has a doctorate at Purdue University. Finally, he serves on the advisor aluminum board at the Graduation School of Management at UC Davis. Please join me in welcoming our speaker, Dr. Venkata Duvuri.
Thank you for the kind introduction. So today my talk is about storefront attention analysis with neuromarketing techniques and developing latent AI attributes with AI. This is part of my lab, Serious Mindshare lab, and we have researchers working on such efforts. So this research explores storefront design. So if you look at storefronts, which is small stores in your neighborhoods, the focus is to how to improve that storefront design with neuromarketing techniques. It is quite evident that small businesses and mom and pop stores, for them, the storefront, which is the front-facing part of their store, is very critical and the first point of contact with the businesses and with the customers. They need visibility, foot traffic, brand recognition, and customer acquisition via these means. So often the struggle for small business owners is to manage all this with limited resources, limited expertise, and limited access to advanced marketing tools. So here we present a way to use neuromarketing techniques via cheap analytics offering at Serious Mindshare to address these needs of visibility, foot traffic, brand attention, and customer acquisition through neuromarketing and AI techniques. The research involves eye tracking studies and using specialized software which have summarized this eye tracking analysis for several millions and millions of images. And we use these eye tracking studies to analyze the storefront and ultimately improve storefront. The visual attention patterns with small businesses is the key takeaway for neuromarketing techniques. And also we look at we analyze the images for aesthetics and visual quality and understand them better. Finally, we present several key factors which improve signage, branding, and the designs of these storefronts. So the problem is that generally storefronts are cluttered, there is poor lighting or inconsistent branding. This is our one finding, that if you have storefronts which are not aesthetically clear, it will affect attracting customers. So AI driven neuromarketing heat map technologies can help alleviate this problem. So the executive summary is that by utilizing neuromarketing techniques, we can improve the effectiveness of storefronts and alleviate the problem of poor aesthetics and improve customer engagement. Neuromarketing techniques have been applying attention heat maps for several decades, and research references citations 1, 2, 3, 4, 5 have all point to that this techniques has gained recognition in recent times. Specifically, there are models like neuroimage assessment, NEMA, and pack to pick techniques have proved itself to evaluate image quality and predict attention. We use these techniques in our research. Also, paper 10, citation 10 has pointed out that architectural style, color schemes, and designs are important in attracting customers. Paper 11 points that proper signage is important as well. Finally, paper 12 is helping or pointing to the fact that storefronts help improve brand recognition. With all this, what we did was, as part of our data collection, we visited 144 stores in San Francisco Bay Area, and we analyzed the 144 store images from San Jose area, and specifically 75 stores in San Jose and 22 stores in Santa Clara and 14 stores in Sunnyvale. These stores are restaurants, cafes, and retail. We take pictures of the storefronts, and so for 50% of them are restaurants, 27% are salons, and 23% are retail stores. This is our data set through collection. Then we analyze the quality of these storefronts, existing storefronts, using pack-to-pick image quality analytics. We found that at least 50% of the stores are poor or fair quality storefronts. It means there is half the stores in your neighborhood that can improve their storefront designs by using techniques. So once again, these improvement in the quality of the stores is across the board, whether it be restaurants, whether it be retail stores, or whether it be salons. All of them need improvements, as you find in these box plots. Now, we use Neurons AI to see which sections of the storefronts customers give attention to, and using heat mapping. So for example, there are 4 images on the left side, which are good storefronts of See's Candies and Pizza Store. And if you see on the right side, the See's Candy brand is not highlighted. It's not super visible because maybe it is too immersed in the background. It is not standing out. The second thing is the Pizza Store, its brand stands out because its heat map is in red attention. So you see that some stores are good, some stores are bad, and that is visible through this attention heat map analysis. through Neurons AI. Neurons is something which we use as behind the scenes platform with insights, attention insights from several million images that they have developed with AI. What we did was, on top of this attention heat map, we created word clouds which help focus on what aspects of the storefronts are visible. For example, the aspects or the attributes of the storefront which are visible are signage, logo, window simplification, window display, curb appeal, and so on. So we help to surface what attributes or aspects of the storefronts are standing out by looking through the view of attention heat maps. A bold signage, service clarity, these are all lighting, these are all standing out. And some of the ones in yellow are not standing out, which is a concern because the customer might want to look at them. So what we have done so far in the research is collected images, analyzed them through attention heat maps, created tags or labels of attributes. And now our job is, what we did in this research is to predict these attributes through a AI or ML model in the latent space. Latent space means these are attributes which have no names. They are in the latent space. They are a mix of attributes like bold signage or window or lighting. They are a mix of those, and these are topic 3, 5, and 6 here. These topics are latent attributes which we try to predict using models, and we try to do that before and after attention heat maps. So this whole research is about getting started analyzing the stores and how effective can you get by using cheap AI ML tools to predict them. In this case, the prior predictions of these latent attributes, which are indicative of the storefront goodness, is around 20 to 30% accuracy and around 0.5 AUC. And once we apply neuron attention heat maps and use the post-processed images to predict the storefront latent topics, our accuracy with these attention attributes increases from 0.2 to 0.4 in terms of accuracies and 0.7 in terms of AUCs, which means using neuron or other attention heat maps, we can predict the latent attributes more perfectly with respect to improving the storefronts through AI tools. And this might ultimately be, or is ultimately a product in our software that we are planning to develop. So in conclusion, what we have done is 3 things. One is we have collected store images. We have analyzed them through quality metrics like pack to pick and NEMA. We have created ML models to predict attributes and their latent attributes and see how attention attributes can improve the prediction of performance. So several things have been accomplished. This is the first in a series of such research topics that we are going to investigate. We have figured out that through this research, we lay out that 50% of the storefronts needs improvements. Secondly, AI techniques can help predict these missing pieces quite effectively by building better and better models. So that is our conclusion. And of the secondary conclusion, XGBoost model is consistently outperforming other models in predicting the latent attributes. So that's our research, and I like to acknowledge the team here which has worked on this research, and thank you. Any questions? Okay, I don't see any questions. Thank you, everybody, and that's my time, and look forward to several future such presentations and discussing my research with you people. Thank you.
Thank you for your time. Thank you.
Now, hello everybody. Once again, I will present, first of all, any questions? Can you hear me?
Yes, yes.
Francesco, come vai?
Well, everything is going okay.
Wonderful, wonderful. So, there we go. We had the most amazing day, and now we arrive at the end of the day, and we'll have tomorrow again most amazing lectures to come.
Professor Dana, sorry
Yes.
for interruption. Our next speaker, Deepak Mukund, is here.
Please present him.
Okay. 1 minute. Yeah. And our next speaker is Mr. Deepak Mukundu. Mr. Deepak Mukundu is a Senior Director of Product for the Agent Force AI platform at Salesforce, leading agent quality, testing, benchmarking, and monitoring capabilities. With over 2 decades of experience in AI, machine learning, and big data platforms, he has held key leadership roles driving innovation. A published O'Reilly author of practical automated machine learning on Azure. Deepak actively shares insights of AI product management and technical product leadership across various platforms. Please join me in welcoming our speaker, Mr. Deepak Mukuntu.
Thank you. Thanks, Kavya. Can you guys hear me well? Kavya, can you confirm if you can hear me well?
Yes, I can hear you.
Okay, great.
Yeah,
Any
can you
other
please
ideas?
share your screen?
Yep, I am going to share my screen right now.
Yeah, thank you.
Desktop 2, okay. Can you see my screen now with the deck?
Yes, I can see your screen.
Great. Okay, let me go full screen and then we will get started.
Okay.
Okay, thank you. Thank you all for this opportunity. Nice to meet you all. I lead product management at Agentforce AI platform at Salesforce, and today we're going to talk about how to build and manage AI agents for real-world use cases. With that, quick precursor on what are AI agents, right? AI agents are basically autonomous or semi-autonomous systems that perform tasks using perception, reasoning, and action. I'll talk about all these three in the next couple of seconds, right? Perception is understanding what's happening around that system. Reasoning is perceiving is like getting to know what's going on. These are like sensors and signals captured on what's happening. And then reasoning basically is like understanding all of those signals and making sense of them, and then acting. Right. So at a very high level, this is what we humans do, which is we look at things, we smell things, we touch things. Perception is that, right? And then we try to understand, make sense of like what's going on. Like if I see something, if I see a child crossing a road, I'll understand that, okay, there's a kid crossing the road. So now for me, it's about safety immediately, right? So that's where reasoning comes in. And then action is like, I'll go and see if I can help that kid cross the road safely. Action. So agents are no different than humans. And basically AI is evolving into a state where a lot of what we do as humans could be automated, which is where some of the key characteristics of agents come in. Autonomy. Autonomy is these systems operate with minimal human intervention or supervision. Intelligence, like I talked about, they can solve problems, they can learn. They don't need to be explicitly instructed like our traditional software where you have to program. You have to say exactly for this use case, this scenario, do this. For if we all have done through software. I've done software engineering where we have written programs, codes, designed things which are very, very deterministic. In this new world, they are all non-deterministic systems. They can learn from what's happening. Adaptability is like changes as the system changes, as their environment change. These systems can learn and then adapt, which is very important. To be an autonomous system, you need to be able to learn and adapt. And then they're not doing random things. They're goal oriented, so you can actually set specific goals and then have them figure out exactly how to meet those goals. So very, very high level, this is what a typical definition of an AI agent is. They can autonomously operate. They can intelligently understand and take action. They can change and learn as situation changes. And then they're all target oriented or goal oriented, right? So one of the key questions I keep getting asked whenever I talk about agents and is what happens to humans and what happens to our future, right? Will all of our work be replaced by agents? The answer is no. Agents are not here to replace our jobs. Agents are here to help us. Agents are here to collaborate with us to make our life easier. So you're already seeing, we are all seeing this trend where a lot of automation is now being done through agents or being envisioned to be done through agents. So I do envision the world to be more humans and AI agents will collaborate to get tasks done more efficiently, and hopefully we will be able to get things done that we have not been able to so far with some of these AI advancements. With that, real world use cases, I touched upon this briefly. Here are 5 broad categories that I believe will be like top of mind. Already a lot of progress is being made in these areas around how AI agents can help accelerate progress. Customer service, right? This is the first one, chatbots. Chatbots have existed for long, but today's chatbots are not human-like. They are very programmatic. They're very programmed, which means that they can't answer questions that they're not programmed to answer, right? So with AI agents, customer service is going to be disrupted. We are already seeing a lot of disruption here. Advanced support agent handling, right? So agents can handle 70 to 80% of what human agents can do. AI agents can do that today, which means that your support staff can be a lot more efficient because 70 to 80% of questions can be handled by these AI agents. Healthcare is the next big one, right? This is where a lot of diagnostic assistance can be done, patient monitoring can be done through this automation. Again, right, this will all be supporting healthcare professionals so that healthcare professional can be more efficient. Finance, fraud detection, we all know this is a big area, huge industry. And the other one is stock and portfolio management. A lot of those things are also things that you can program to a large extent. We have seen a lot of people investing in this space, a lot of companies investing in this space in the past. With AI agents, I believe that this space is going to evolve significantly because these agents can learn. Manufacturing, predictive maintenance, we all have seen AI used in predictive maintenance. I believe that area is going to also be significantly helpful with AI agents coming into picture. Software development, this is where you're seeing a lot of new coding tools, vibe coding, those patterns emerging. That's because now we have this technology which can help us start from blank slate. You can just have like a couple of instructions to say, oh, right, I want to create an application like this. And then it'll go ahead, the system can go ahead and generate full code for that application. And then you can also tweak things, right? If you already have a program written for an application or you have a full end-to-end stack for an application, you can ask an agent or a system, AI system, to go and debug things, to go and test it. So a lot of investment is happening in this space. We have seen like GitHub Copilots emerging, vibe coding tools like Cursor. I don't know how many of you have used. If you haven't, please do try. It's amazing how human-like these softwares are emerging. With that comes what does it take to build these agents, right? So I talk about this in four stages usually, and if you look at these 4 stages, there is nothing unique about agent development here. This is like typical software development, right? You start with defining a purpose. Why do you want to build this agent? What problem are you trying to solve? So clearly articulate your use case and then your business objectives. Next is build and test. You architect your system, you figure out like what should, in a typical software world, you talk about like, oh, what should my database layer look like? What should my middle tier layer look like? What should my application layer look like? And what should my user experience look like? So that's what you typically design. And then you go and build and test those using a good set of rich test cases. AI agent development is no different, except that there is a lot of non-determinism. And we will talk about some of the next steps here. But one of the key things to keep in mind as you build agents, as you build any of these new AI-powered experiences, is how do you measure quality? As you can see, like if you are interacting with ChatGPT or any of these AI products, you ask it one question, you'll get an answer. You ask it the same question again, you will get a slightly different yet still correct answer, which means that you cannot test these agents using a deterministic approach. You have to figure out ways to verify the non-determinism. Right? There are a lot of interesting patterns emerging here around LLM as a judge. I don't know if you've seen, you can use LLMs to judge work of another LLM. You can use LLMs to judge whether an agent is doing good or not. You can use an agent, you can build an agent to test your agent. So a lot of meta patterns are emerging here, but that's important to keep in mind as you're building agents, that this is not a deterministic system, which means that your approach to testing for quality, testing for completeness, testing for even monitoring needs to have a lot of non-deterministic aspects to it. The third step after build and test is deploy. So you need to make sure that you have a good deployment strategy wherein you and again, this is nothing new. You need to have a good rollout strategy, starting from doing some internal testing, some dog fooding, small alpha user testing, beta user testing, and then when you go to production, also have some approaches around gradual rollout, A/B testing, and then more importantly, have feedback loops, have enough instrumentation, have enough feedback collection mechanism with your users so that you get the feedback. And these systems are, we talked about it in the beginning, these systems are learning systems. So they can learn if we can provide them feedback. So feedback loop is important, like any other software, but in this world, this lot more important because the system itself can learn. The last one is monitoring and improvement. This is where you talk about make sure that you have good performance metrics. And with the feedback loop, you have a way to iterate. You can fine tune your instructions. You can fine tune your prompts if you're building an LLM-based application to make sure that you have a good way of monitoring and improving your system. Okay, with that, we'll dig deeper on each one of these aspects to the next level of detail. Define purpose, right? Again, like I said, this should not be anything new. If you have already been in the software industry, this is the first step of any project, any product you build. You start with purpose. You start with what is the business problem you're trying to solve. Do not start with technology. I'm seeing a lot more of this emerging as a problem in the AI space now because LLMs have revolutionized everything we do. So most teams, most companies, most organizations start with technology. They start with, oh, we have this great AI. What can I do with it? Yes, that is a good high-level problem statement, but do not, when you get to the next level of details on like what should I build, don't start with, oh, I have this technology. Let me try to wrap this around something to do blah. Right? Start with what is the problem you want to solve? Where are your customers struggling? What is the big investment area for you that you think will be the next big thing for you as a business, as a company, as a team? Then work backwards from that business problem and then figure out what the right technology solution should be. How do I use AI for doing that? So that should be a second question, not the first question. Identify tasks that are best suited for automation. So when you try to define your problem, whether to use AI or not, how much to use AI or not, should be based on how much of that can be automated. How much of that can be done in a repeated fashion is what you should look at when you look at picking up what AI investment will be helpful. Then, like typical investment, any investment have clear KPIs and success metrics. I have seen a lot of teams and organizations struggle with this now, especially in the AI world, because AI is not free. These large language models and huge investments around that ecosystem does cost a lot of money. So make sure that you're very clear on what is the goal, what are the KPIs that you're trying to measure, what does success look like, and then as part of success, you can also make sure that you have some sort of ROI built into that success measurement. Stakeholder expectations and requirements are the next things you need to make sure that once you have your goals, then you figure out like who are the users and what do they need and how do you make sure that your investments are meeting their requirements. And then always balance technical feasibility with business value. This is very, very important. Again, there are a lot of interesting technical advancements that we're going through, but make sure that you balance those with the business value. So overall, if I were to summarize this slide, it's about start with business problem, start with customer problem, do not start with technology, and then have a good balance of technology and business value, and then have the right KPIs and measurements to be able to measure that on an ongoing basis. Next is build and test. So these AI systems, I think I talked about a typical software stack where you start from what should my database technology be? What should my middle tier technology be? What should my application layer look like? What should my user experience look like? With AI, the 4 key components or the 5 key components you can think of are, first is once you have defined what problem you want to solve, these are the first 4 are critical pieces. One is, what is the foundation model? What LLM do I want to use? Again, like don't stick to one LLM, but as you start building your system, you start with what is the most apt model that you think is good for this use case. Again, should be based on what capabilities your use case needs, what are your latency requirements? Not only functional requirements, but also latency and cost requirements also become important here, because models come in various sizes with various different capabilities. So you need to figure out what model is best for your use case. Then comes, once you have the model knows something. The model has been pre-trained with huge volumes of information, but still it doesn't know your specifics. Your organization may have your own specific information, your own specific data that's sitting in various data sources, maybe Snowflake, maybe some databases, both structured and unstructured data. How do you bring those into your design so that your model not only knows what it is trained on, but also can use your information? This is where the second piece comes in, which is retrieval systems. RAG, if you have heard, retrieval augmented generation. It's all about how do we bring the knowledge that we have, like our organization has, to this system so that the large language models can not only have their knowledge, but also can use your knowledge. Third one is around planning component. This is where I would, in my first slide, I talked about these systems can learn and can act on. So for it to learn and act on, you need to help it break down the task into smaller tasks. A lot of these LLMs today can do it. Like if you go to Claude and ask it a complex question, the model itself will break it down, and you can ask it, you can prompt it to say that, can you describe your thought process? It will actually go and describe you, like I'm breaking this problem into n different steps, and this is how I'm going to approach step number 1. This is how I'm going to approach step number 2. So the LLMs are becoming more and more powerful. They can think, they can reason out. But in a business use case, or in a use case that you want to completely control, have a good control on, you need to guide it, which is where these planning components come in, where you can break down your task and then you can have a good decision-making model. So that's something that should be part of your architecture. And the fourth one is tool usage, right? LLMs can do a lot of things, but they need to have access to data, which we talked about in the retrieval system bullet point. But they also need to have access to various APIs and various tools that can act on. For example, if you have a simple agent which sends email out, or which sends a message out to your users, you need to have whatever that component is that sends email out, that you may already have built as part of your application or your software. You will need to make sure that this system, this new AI system you're building or AI agent you're building, has access to those tools so that it can use your tools to reach out to your users. Right? So that's where tool use comes in. So these are the four broad pieces of the AI architecture as you're building agents. But then comes two other important aspects, right? One is safety. Safety mechanisms need to be in place. These LLMs and any generative AI products, they are very powerful. They are very innovative. They can reason out and take action. But you also need to make sure that they have the right guardrails. They have the right human oversight, so that if things go wrong, that you can correct. But then first step is even making sure that things are going on track. So guardrails becomes an important aspect here, and there are a lot of great progress being made here around how do you establish guardrails as you build your agents. You can have guardrails around, oh, I gave this agent these instructions to follow. Is the agent really following instructions? You can do that today. You can actually use another LLM to do that. Think of it this way: there's an LLM that can do guardrail check for you. You can send it all the instructions you gave to the agent, and then at runtime, when the agent acts on individual tasks, this guardrail LLM can actually monitor this the main agent and tag whenever things are not being followed. So that's where we are. Right? That's slightly meta, but a lot of LLM-based safety checks are emerging as key trend here. So make sure that you use these approaches when you build your agents. And the last but not least, testing. I talked about it briefly. We need to make sure that because these agents are not deterministic, our testing approach should also be a combination of deterministic checks and non-deterministic evals. Deterministic checks are things like, this is the output I'm expecting. When I give input A, the output should be B. You can check that deterministically. You can check that is the actual output same as the expected output, in this case B. Non-deterministic evals are things like, I expect the response of my agent to have a summary of this conversation. Note that here we are not saying the expected response is here is this is the summary of conversation. No, because you don't know what the exact summary should be. So you need to have a non-deterministic way where you can actually specify and use an LLM as a judge to judge whether the input, whether the expectation that you have, you can describe in natural language, you can describe in English, and then that judge will take that as expectation and then map it to the actual and then say if it's yes or no, if it's pass or fail. I know it's a little meta, but this is where we are going. The industry is heading towards making sure that we can use LLMs and generative AI and other agents to test and verify the agent you're building. The next one is deploy strategically. This is where things like rollout. How do you test, learn, scale? Sorry, was there a question? Test, learn, and scale. This loop is something you have to optimize for, and it all starts small. And this is something that I tell everybody who is building agents or AI systems is don't try to design the whole thing completely because you're not going to be right anyway. Start small. Start with one use case, just couple of flows, and then define that, test it, ship it. We are in this world where while quality is important, speed is also important. Like if you're not moving fast, then you are going to get outdated. So make sure that you can have small MVPs, ship it, learn from it. That has been a mantra for a very long time now, but then it becomes even more important in this new era. So make sure that you have a good rollout approach. Human in the loop is also important. Like you make sure that as you have your MVPs, don't go fully autonomous. Have human in the loop. Humans can look at the response, can look at agent actions, and then maybe correct the agent or guide the agent. So start with that, and then slowly, gradually move towards like semi-autonomous systems where only if automation says something may be wrong, then have humans look at it. So have that kind of gradual step-by-step human in the loop transition planning. Right? And then user training and change management. This is huge. Users are also going through a huge learning curve here. Users meaning your customers who will be using these AI powered systems. They also need to be educated around what does typical good response look like. What should they do if an agent's response is incorrect? So all of users need to be trained on like ability to give feedback. So give feedback. Make sure that if you see something wrong, give feedback, and then the system will learn and improve. So that mindset, it's not just the builders or people who are building these agents need to have that mindset. Users also need to get into their mindset, and that I think is happening already, but a lot more to be done here. Make sure that your user interface brings these kind of aspects to your users. Supervision and oversight is also important. So this is where like some of the feedback loops we talked about. So feedback collection and supervision. So you collect enough feedback so that you can supervise. You as a builder can supervise. And then there is also interesting trends here around how do you use other agents to supervise your agents. So first step where we are bringing agents into is doing a specific task. Now there are discussions and there are trends emerging where you can have supervisor agents who can supervise other agents, and then by supervising other agents, what I mean is performance managing them, looking at are the agents doing well, are the agent getting enough traffic, are they responding well, what are the quality of the response of the agents, what is the latency of those responses, cost wise, how is that agent doing. So all of those are interesting aspects of measuring whether the agent is doing well, and we are seeing a pattern where even that supervision is being envisioned to be done by other agents. So supervisor agents, if you have heard, is where we are moving for this area. Okay, monitoring and improvement. I think I briefly touched upon this. Performance dashboards and analytics, again, very important like any other product, more so important in AI because these are autonomous and semi-autonomous systems. User satisfaction and experience metrics, again, thumbs up, thumbs down is a good way of capturing user satisfaction. Also implicit feedback, like did the user do what you were expecting them to do when the agent provided them some information. So those are implicit signals. If you can capture that, you can measure user satisfaction. Error analysis and root cause, again, like tracing is an important concept. Session tracing, or the tracing of the full end-to-end session between the agent and the user, is important, because that way you can have the rich information for you to go troubleshoot. If you think the user is unhappy, then you have the log of exactly what happened. Again, a lot of this is not new. A lot of this is existing investments. It's just that some of these things are becoming a lot more important in the case of AI and AI agents, because these are autonomous and semi-autonomous systems. And these are non-deterministic systems that you're not coding explicitly for. Model drift detection is critical as well. Regular retraining and capability expansion. This is very, very important. It's not just measuring performance and learning from it. It is also like, how do you take that learning and retrain? How do you improve your prompt? If you're an LLM-based system, how do you improve your prompt? How do you improve your instructions, your agent instructions? And how do you improve your models? How do you fine-tune your models for your specific needs? This is super, super important final step in the monitor improve step. Okay, so I think this slide talks about real-world challenges, hallucinations in quality, latency and cost, regulatory constraints, adoption resistance, user adoption resistance. I don't want to take more time. I know I'm hitting my time here, but we touched upon these 4 aspects in the 4 stages that we went through. For hallucinations quality, have robust testing tooling, testing approaches in diverse scenarios, and have right guardrails. Right? Latency and cost, this should be done mostly through initial planning and through continuous monitoring and optimization. Regulatory constraints and privacy constraints, how do you make sure that your agents are following regulatory restrictions? You need to explore like privacy preserving techniques. There are a lot of techniques that were already there before the LLM era. A lot of those are relevant still. And then the data handling, make it as transparent as possible, give users control as much as we can. Adoption resistance is an interesting one. This is where I talked about, as you design your user experience, co-design it with your end user. Like, show them what you're trying to build, get their feedback. That way they're not surprised because these systems are different than our traditional systems. And then clear value. Also, as you engage with those users early in the life cycle, show them the value, tell them why it's important, and then see if they have unique point of view that you want to accommodate. Okay, so I think this is the last slide almost. Agents are powerful. They are not magic, right? You need to start with a clear business purpose and very well-defined steps to get to the business purpose. Follow your engineering rigor. This is like any other engineering problem you've solved in the past. This is the same. You need to have a rigor, build iteratively with feedback loop, and that you can monitor and improve continuously. Focus on user value and reliability. This goes back to the clear business purpose, but I want to reinforce it. Focus on user value. Don't start with technology. Don't focus on just technology value. Build organization capabilities alongside technical users. This is important. This is super important. We talked about a lot of technology and how you think of technology so far, but it's also mindset, right? Make sure that your organization is geared to taking this mindset, right? I'm seeing this like everywhere in our organization, in many other organizations. Typically, people feel like, oh, I cannot ship this because there's no quality. I need to make sure that this is tested completely, thoroughly with like hundreds of test cases, thousands of things, and only then I can expose it to my users. No, that thinking has to change. That thinking really has to change. You need to make sure that you can start small, ship small things, learn from your users. A lot more important now than before. And then the other one is the space is evolving super, super fast. Like every day I see something new coming up. Every week a new model was being released. Every week new paradigms are coming up, right? Now there's this agent to agent protocols coming up where how do we make different agents interact with each other? MCP, if you've seen, is a way for us to like have different tool connectivity. Like how do you bring standards to it? So this is not end of the world. This is not done. This is still changing. This is still evolving. So the key to success is stay flexible and keep learning. Have the learning mindset. With that, I think I am done. Questions?
Wonderful and great inspiration to be courageous and to put your product on the market right away. That's well done. Anybody have any questions? It was a very beautiful presentation. Congratulations. And let's see again if they want to ask you
Thank you.
questions, our colleagues. So what if the product that you have, once the customer says, I cannot use it, it's too hard. What do? You refund the customer?
Sorry, what product are we
if
talking about?
if your client refuse your product, rejects your product, what you gonna do?
I think this is where you should not reach that stage. Because if you built it right, if you engaged with your users from day one, you would build the right product. You would build the right product for your users, right? What you're asking about is a situation where I would think you should not even get to, because by the time you get to a stage where you say, oh, my users are not liking my product, means that you have lost the battle already. And that's how I think of it.
Do you think, answer please, between statistical interference and AI, what is the difference? Why is AI different than statistics?
Statistics is, so I think it's an interesting question. The reason I'm thinking so much is AI has also evolved.
Like
in
what?
the last, right? AI has also evolved. Say, initial AIs, if you look at it, were statistical models. Like initially, when people started talking about, oh, I want to do anomaly detection, I want to do like prediction, logical regression, logistic regression, all of those were based on statistics, right? Those are the foundations. So I would not say statistics is very different from AI. Initial versions of AI were very close to statistics because they were built on that, like numeric analysis and stuff like that. The most recent trend that we are into in AI is a lot more than statistics. It's a lot more of like a pattern matching from your data. So that's what I would say is different. Like statistics is pretty deterministic, while where we are right now is very, very non-deterministic because it's starting from pattern, looking from patterns. Unstructured data and pattern matching is very different than structured data and statistical analysis. So that's how I would say.
Looking for buttons?
Say that again, sorry.
Back and matches, you said?
Pattern matching. Pattern matching.
Patterns. So that's the difference.
Yes.
Looking for
Yes.
patterns.
So I would say statistical analysis is for structured data and doing deterministic analysis, while the AI that we are in right now, the AI trend we are in right now is unstructured data and pattern matching.
Pattern matching.
Yeah. So think of it this way. Another way of looking at this is, how do humans operate, right? You don't operate always in a structure. You don't know that you can be thrown any information, right? Any new situation, how do you react to it? You're not coded to react to all situations, right? You still are able to figure out something from that new situation. That is where we are going in AI. Right? Previous versions of AI was not that. Previous versions of AI was, there's a table of information. There are 4 columns of data. Now you need to predict a 5th column using these 4 columns, right? That's very structured. Now we are saying, oh, there are these n different images. Now, can you figure out what is in the image? This was deep learning. Now it's like a lot more deeper than that with LLMs is how I look at it. Lot more unstructured data and pattern matching.
Pattern matching.
Yep.
Do you apply for grants? Have you applied for grants?
I haven't applied for grants.
No. Pattern matching. So this LSM, did you create it yourself? Did you invented it?
So sorry, I think
The product. Did you invent the product?
maybe I should clarify, right? I did not do a product pitch today, right? My approach was I just shared how to think of AI, how do you build AI. In this case, my company is building a platform for others to build agents on top of, right? So it's not my individual thing. I'm here just to share my knowledge on what I'm seeing from customers and organizations as they're adopting AI. What are some challenges? How to build AI products in this new world. That's what I wanted to share with this group.
Somebody had a question for you. Who's that? Please unmute yourself.
Hello.
Hi.
Yeah, hi. This is Terrence. I have a question. I mean, thanks for your sharing, by the way. I was telling Sunny that, some of the insights that you shared were really, really valuable. I'm gonna make this available to my team. I have a question about how small startups without the resource capacity of Salesforce might go about implementing some of the suggestions that you've mentioned here. And I understand this question is probably very wide ranging, right?
No,
But if you
it's
were
a
to
great
advise a
question.
smaller startup, yeah, what do you what do you
It's a
think?
really great question, right? And I think it's a lot more now than before. Small teams and small companies, small individuals can also easily get into AI, right? You don't need a huge investment around like a big platform or whatever. I would say if you have not already started, try Cursor, try Replit. These are vibe coding tools that can actually help you build a full end-to-end working prototype in a minute, in few minutes or hours. And I've tried it and I'm really amazed. Right? You don't need to have full stack engineers building the system and whatnot, right? Just start with it. And you'll be amazed to see like how amazing the output is within minutes. And then the beauty of at least Replit that I tried with a few examples is it not only builds the first prototype in minutes, it also you can actually play around with the prototype and say, oh, this is not working. And then it'll go and look at the code and it'll tweak the code and it'll fix the code for that use case. So it's so interactive, so amazing that I feel like you don't need army of people. You don't need a big team. You can actually start very small, get the prototype out, get your users to validate that. And then if you think that there's enough there, then go and build. So that's what I would say as a easy to get started advice.
Thank you, Doctor. You're an inspiration, and please teach me some more. I left your message. Please
Thank you.
teach me more, please. And we look forward to see you at the next lecture. Can you come tomorrow to the panel discussion?
When is that? I don't think I have it on my.
5 o'clock, UK time.
I will confirm. I think I'll confirm through Kiran. I think I'm working with Kiran.
Yes, please, but because I personally want to invite your expertise to respond to the questions from Professor Richard Nielsen. And we have to defend AI. And please come. It's important. Yes?
Okay. I will confirm. Yeah. Okay. Is that all? If there are no more questions, I think we are done, right? Thank you. Kavya?
Yeah. Hello.
Kavya, anything else? What's next?
Yeah, we will go with our next speaker.
Okay. Thank you, folks.
Thank you for your great presentation.
Thanks.
Yeah. And our next speaker is Dr. Rihanna Landa Mohammed and Terence Tan. Dr. Rihanna Landa Mohammed is an educational consultant, instructional designer, and edtech strategy with over 20 years of experience. She is a creator of the Extreme curriculum. She pioneers innovative technology-driven learning experience, focusing on STEAM and Extreme education. As a founder and CEO of Extreme Sunshine Path, she develops and implements cutting-edge educational initiatives emphasizing critical thinking and personalized learning. Dr. Mohammed collaborates with edtech firms like Edmarkle developing AI-powered lesson plans and has cooperated with stakeholders in the Florida Department of Education on best standard practices. A sought-after speaker, she presented at conferences like FETC and ISTE. Her leadership roles include Director of Instruction at the Florida Educational Institute and worked at the St. Antonis Schools of Higher Education, where she implemented successful STEAM programs. Dr. Mohammed holds dual doctorates from Nova Southeast University and is a certified Intel Skills for Innovation ambassador. She actively engages in communicate initiatives and serves on advisor boards. Her work has been featured in publications and media, highlighting her contribution to digital learning and instructional innovation. Terence leads the expensive of Edmark's Teams program in the USA, alongside serving as the product manager for ED. He holds AEDM from the Harvard Graduation School of Education, focusing on human development and educational psychology. Terence was formerly a higher education policy officer in Singapore Minister of Education and began his career as a high school English and history teacher. Terence is a certified serum manager, project management professional, and an InterSkills for Innovation certified trainer. Please join me in welcoming our speaker, Dr. Rihanna and Terence.
Good morning, good afternoon, good evening, good night, everyone. Thank you so much for allowing me and Terence to be a part of this community. Thank you so much, Kavya, for that wonderful introduction. So you already did our introductions for us. As you know, Terence and we are part of Eddie and eStream. We met approximately 2 years ago, and we flourished together, both of our companies together. So the eStream curriculum, it's built on your STEM and STEAM concept, but the only difference is that with the eStream curriculum, I've added entrepreneurial skills and research. Now, in partnership with EdMaker and Eddie, we have your maker cards and all of that embedded into the curriculum. So it includes the prototyping, the 3D printing, the computer-aided designs, the computer programming that allows our children to do all of these things together. They also have the hands-on circuitry where they have the little strips and they can build circuits together. Physical computing, IoTs, and virtual reality all built into everything together.
At this point, maybe I'll just add on to what Rihanna has already shared. I think the eStream curriculum that we've developed, a big part of it is a focus on learning by doing, right? Because in our experience, we know that our students, a lot of them don't learn best through academic work, meaning that when you ask them, what's 2 plus 2? Like many of them, their eyes glaze over, right? But when you give them hands-on manipulatives, you ask them to create, to build, to create artifacts, that's when they get really excited. And that insight and that realization is really at the heart of what we've developed. As EdMaker, we have been spending the past 8 years honing our skills and helping students learn by doing. And so a lot of our focus is on fully hands-on stuff like on the left, cardboard prototyping, hands-on circuitry, physical computing with a microbit and makey, as well as digital fabrication. But what we've seen recently is a move into what I like to call digital making, right? Which is the idea that students are creating not just with their hands on cardboard and using physical manipulatives, but in the digital world. What does it look like when, for example, students can use Replit or Cursor, as Deepak mentioned before, right, to build a functioning prototype of a website in minutes? What does it mean when students can use GenAI tools to create STL or templates to help in 3D printing, right? They don't actually need to create the full model in a 3D printing software. They can use generative AI to create that. What happens when all these tools open up a whole new space for students to build and create artifacts that they can subsequently monetize and commercialize? And that's the kind of future that we're going to, and that's really the background underpinning our whole eStream curriculum that Rihanna mentioned. Yeah,
Thank you so much for
Rihanna.
that, Terrence. So the eStream curriculum, it develops the essential skills that our children need, such as the critical thinking, the problem solving, creativity, technical and technological skills, collaboration, and it also focuses on SEL, which is your social emotional learning. It incorporates all of this into the curriculum. For the social emotional learning aspect, the children, they learn to develop a positive relationship and teamwork. They work on judgment making, decision making. They learn empathy and social skills, how to work together with others. And these are skills that they need going out into the job force, especially how the world is changing on a global aspect. Everybody is looking to know that you have these skills already embedded in you. And eStream is teaching these skills from kindergarten all the way to 12th grade. We have the mindset skills that focus on the design thinking, the computational thinking, system thinking, creativity, inquiry-led approach. And the students, they learn by doing, they learn by actually applying the things in the classroom, the hands-on learning, like Terrence explained. It allows them to expand their mind, expand their horizon. It's not just that rote memorization that we had in our classroom when I was going to school. You memorize something, you learn it, and you don't really transfer that knowledge with the hands-on aspect while you're applying it and you're doing it. You tend to recall the information quicker. So that is the skill sets and the mindsets that eStream is embedding into our students. It focuses on critical thinking, the problem solving, communication, for the research aspect. So the children have to do the research in order to find the information, the methodologies of research. They focus on experiments and how to analyze these data. And it focuses on questioning and gathering the data that the students learn from their research and how to apply all of that into the classroom. Therefore, they transfer all of this knowledge once they come out of school. For the entrepreneurial skills, it develops that ownership, that sense of ownership, something that I have, something that I created. It gives them that purpose and understanding that since the world is changing so much, there's different avenues they can pursue as far as starting their own business, an e-commerce store. At our school, we launched an e-commerce store, and this was done by our middle school students. And our school store has all of our school uniforms, school swag, lunch boxes, all of that pertaining to our school. And all of this was done by our students. So it's teaching them that skill set. Okay, I could do this from a very young age. Now, Terrence?
Oh, and so yeah, and so a big question, when we share this with teachers, right? I will be pretty upfront to everyone. We are educators at heart, right? I taught high school, K-12. I taught high school history and English in Singapore at the start of my career. So we are educators at heart. And so when we share about eStream with teachers, a major question that we often get is, this is a great curriculum, but it runs counter to what a lot of teachers are used to teaching, right? I'm used to taking a curriculum that teaches that approaches students in a much more didactic kind of pedagogy, right? Whereas the eStream curriculum is really premised on project-based and problem-based learning, getting students to create by doing, like they learn by doing, right? So one big question from teachers is, is it easy to implement? it looks like it's super challenging to implement. And that's why Rihanna and I have actually developed a Gen AI curriculum assistant, Eddie, that helps teachers. It just takes minutes to integrate eStream into your classroom using this Gen AI curriculum assistant. So I'm going to share a little bit about how this works. Next slide. So as a teacher, right? Yeah. I go to this our platform and I'll key in the topic and description. So let's say I want to teach about the life cycle of plants. I key that in, I key in the grade and the subject that I'm teaching. And then crucially, I key in the eStream mindsets and skill sets. All of these were mentioned by Dr. Rehana just now. And so I can choose to key it in or leave it empty and let the system choose for me. I can also select software that I want to integrate. And we currently have a selection of 10 different maker-centric software. After clicking generate, the system will give me, our platform will give us 3 different options of potential lessons with a blurb for each lesson. As a teacher, I'm going to read each of them and see which one aligns with my lesson objectives the most before clicking on Build Lesson Package to build it out. It takes around 1 minute to build out the full lesson package, but we're going to skip ahead today. And the full lesson package contains of the lesson plan, key vocabulary, prior knowledge, everything that a teacher needs to use in their classroom, and crucially, the slide deck. All right? Teachers can copy the slide deck that was generated into their Google Drive in a very intuitive interface. And these slides are also available on the lesson plan within the platform. I'm going to share what the lesson plan looks like. Each slide can be actually previewed, right? You can scroll through and look at each slide as well as the teacher prompts or the teacher remarks that guides the teacher in executing the lesson. The teacher is also able to download the whole lesson plan in a PDF. Because when I used to be a teacher, I used to print out lesson plans and bring them into my classroom to help me. So you can see that each lesson is broken down into intro, a main, and a closing. It's a sequence that many teachers are really used to: opening a lesson, conducting the main activity, and then closing the lesson. And so for example, in this particular lesson, the teachers are actually getting students to classify different types of plants using a tool called machine learning for kids that teaches students about AI's ability to classify and categorize. In training their own model, they're not just learning about plant classifications and their life cycle, which are pretty much aligned to science academic standards, but they're also learning about AI skills, right? They're learning about how to classify, they're learning how AI categorizes. And what I'm sharing right now is when a teacher actually builds up, goes to the slide, they might make some changes, they might make some edits to the lesson, but a lot of the content there is already there for them to for them to develop and for them to customize further. We're currently in open beta, which means that our platform still needs a little bit of work, but it's really usable. And Dr. Rihanna has actually been using it for the past few months in her classroom. So that's pretty much a short demo of our product right now. Next slide, and we'll see the impact of this demo on the next slide. So what we find out when we've tested Eddie in classrooms, we generate eStream aligned lessons in just 1 minute. So that frees up valuable teacher time. If you ask teachers around the world, they spend 7 to 12 hours lesson planning a week. This is a huge amount of time that could be better spent supporting students, facilitating group discussions, doing a lot of the things that AI currently cannot do, right? Doing a lot of the human aspects to lessons and human aspects to teaching that AI currently is not in the best position to do, right? Allowing teachers to reclaim their time, right, by recouping 90% time savings can allow them to deploy eStream at scale while still retaining their weekend time. Next slide. So when Eddie and eStream are used together, the impact on students is transformational. And right now, Rehana is going to share with you just how transformational this experience was for our students.
So thank you so much for that, Terrence. As you can see, and what Terrence had said, I've been utilizing this platform, the Eddie eStream platform, in my classroom for several months. Even though it's in beta phase, our children are learning and have grown so much with all of this new technology. To the left of your screen, you can see that here our students are learning how to code using one of the platforms called Pencil Code. Here is a classroom discussion that we're having utilizing the platform, and it's all project-based learning. So it integrates all of the technological skills that our children needs to flourish for the 21st century. The standards, our technology standards are also aligned with the ISTE technological standards. And it's also aligned with our UNESCO 2030 goals. That was one of the reasons why eStream was invited to the UN the past couple of weeks in New York. Here are some real life class students in my class.
And at this point, I'll jump in and say that many of these students had not used a lot of these tech tools that we were introducing to them. For many, it was their first time using tools like Python, using tools like machine learning for kids, using tools like Canva. But through eStream, they really discovered how a lot of these tech tools cannot just be used to consume media, but to create media, right? To create artifacts, to create examples of their own examples of artifacts that demonstrate what they've learned about an academic topic. And to me, that's so precious.
And this little child, she's in second grade. So she's exposed to all of this technology in second grade. So imagine learning this technology and these skill sets and mindsets from lower elementary, kindergarten, all the way to 12th grade, and it scaffolds on each other. The students are coming out of high school with all of these skills already embedded in them, which makes them marketable in the job market. As you can see here, we're utilizing different technological platforms from the Eddie platform in our classroom, and it's evidence-based practice since it includes our social emotional learning, the mindsets, the skill sets, and it scaffolds from kindergarten to 12th grade. And like I said, all of our students build on each other. All this core subjects are incorporated in the different classes. So in math class, for example, they'll be getting their reading, their language arts, their science, and their social studies in math. In science, they'll get their math, their social studies, their reading, and their language arts. It's all embedded and scaffolds on each other from kindergarten all the way to 12th grade. I started implementing the eStream curriculum at our school back in August when our school year started. And I am in the process of conducting our end of the year assessment. So if you look here at the bottom where this arrow is at, this was our beginning, our baseline test. And the top one, it's our end of the year. This is our reading data. As you can see, the green with the black lines mean that our students are mid or above their grade level. The red, they are 3 or more grade level below. So comparing from our baseline in reading to our current end of the year testing, which was concluded last week, our scores and our students' learning has improved dramatically. This is our math one, the same thing. The bottom, it's our beginning, which was done back in August of last year. And the top is the one that's currently being assessed now. I'll be finished by this week. So I ran this data just for this conference. And again, as you can see, the red with the black line, which is 3 and more grade levels below, the red is 2 grade levels below, has dramatically decreased in the end of the year testing. And the green with the black, meaning that they're mid or above grade level, has dramatically increased. So this is the data that proves that the EDDI and eStream curriculum together, built on that platform, is working. So it has a comprehensive it is the comprehensive education solution that's focused on building the student as a whole, as an individual. It gives the students everything they need to thrive in every aspect of life, going into the workforce, coming out of high school, getting ready if they want to go on a college path. It's preparing them for that. If they don't decide to go into college, they want to go into a CTE or into the job workforce, they have those skills in the portfolio to back it up based on this curriculum. And if you would like to know more, you can scan the QR code. It has the data. The end of the year data is also coming soon attached to that. And it has the link to the platform to sign up. Thank you so much for your time. We're open for any questions and comments if you have.
And the use of the platform currently in its beta phase is free. 100%
Yes,
free. A cost of $0.00. Yep. We'll take questions.
Absolutely free.
Are there any questions? Thank you very much for a great presentation, Dr. Rehana and Dr. Terence.
Thank you so much, Kiran, for having us and allowing us to be here this morning.
Professor Dana, do you have anything to say? Professor Dana, you are on mute. Just a minute, please.
Wonderful, wonderful presentation. Thank you for your beautiful presentation. Any questions? Wonderful presentation. Congratulations. Any questions?
Thank you so much, Professor York, for allowing Terence and myself to be a part of this. Thank you.
Thank you. And feel free to connect with us over LinkedIn if there are any other questions about our work. Happy to engage with our audience separate from this call.
Wonderful. Well done. It's very important. Your work is important. And everybody take the QR code. And will you be with us tomorrow? Will you look at the lectures tomorrow?
Yes, ma'am, I will.
We have the panel discussions and everything, and we will catch it tomorrow. Now, I congratulate you for your work. Children are the future. It's very important. Education is key. And we congratulate you for your beautiful work. Now, everybody will see you tomorrow. Any other questions? If not, this will conclude the day. Yes, Kiran?
Yeah, nothing else from my end, Dr. Dana.
This will conclude the day. Thank you
Yeah.
for the conference.
Yeah, we'll join tomorrow at 10 a.m. Okay.
See you, everybody, and Dr. Rihanna tomorrow at 9 a.m. And well done. Congratulations to everybody for your beautiful work. God bless, and see you tomorrow. Lots of love.
Thank you, everyone. Have a wonderful day, rest of your evening, and happy Mother's Day to all the mothers out there.
Thank you. Happy Mother's Day. And thank you, Kiran, for your beautiful work. You selected a beautiful, beautiful group of researcher, and AI is grateful to you. Good
You're
night,
welcome. Yeah, bye, Dr. Mukund. Bye, Professor Antonio, Professor Emma, Professor.
Thank you. Goodbye.
Yeah, bye, everyone. Bye, Dr. Eliza. Bye, Dr. Bogdan. Everyone on the call, okay? Thank you and bye. We'll join tomorrow at 10 a.m.